Hello there, and welcome back to the Sleep Science. Tonight, we're slipping into something a little darker than usual, literally. Out there, past the glittering pinpricks of starlight and the sleepy hum of the Milky Way, lies an enormous absence. A space so empty it bends our segments of time and distance, a substance stitched through the universe itself. You're sitting right inside it, by the way. Or at least that's what some cosmologists suspect, that our home galaxy drifts inside a titanic cosmic hole, a bubble of almost nothing spanning hundreds of millions of light years. You probably won't survive this particular realization, but don't worry, it's only existentially fatal. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And drop a comment telling me where you're listening from and what time it is there. I love seeing our little cluster of night owls scattered across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start in darkness, which feels appropriate. The space between stars isn't empty, it's full of invisible tension, radiation, the occasional lonely atom wandering through. But the space between clusters of galaxies? That's emptier still. Imagine standing in a cosmic desert where every grain of sand lies billions of light years apart. That's roughly the scale of the voids scientists map today. They call them supervoids, not because regular voids were too tame, but because these ones stretch across hundreds of millions of light years, like celestial sinkholes carved into the fabric of space-time. The strange part is, you might be living right in the middle of one. The KBC void, named after three cosmologists, Keenan, Barger, and Cowie, has been proposed as a massive underdense region that might include our Milky Way, a vast underfilled sphere where galaxies are fewer and farther between than the cosmic average. Historians still argue whether such a void could meaningfully alter our measurements of the Hubble constant, the rate at which the universe expands, but the possibility is tantalizing. What if our cosmic neighborhood isn't typical at all? What if our whole sense of scale, time, and acceleration is skewed because we're measuring from inside a hole? As you picture this, the human brain does what it always does when faced with infinity. It panics slightly, then starts decorating the idea. Maybe you imagine yourself on the floor of an unfathomable pit, galaxies clinging to the walls like dust motes in candlelight. Maybe you picture a bubble so large the entire observable universe could float inside it. Then you remember, helpfully, that observable universe already means everything we can ever see. Beyond that horizon, even light hasn't had time to reach us yet. And somewhere, out there, might be other bubbles, stacked like cosmic foam. The universe, it seems, is frothier than a badly poured latte. Astronomers have mapped thousands of these holes, using redshift surveys that chart how galaxies scatter through space. The denser regions, clusters, filaments, walls, form luminous webs, while the gaps between them look eerily vacant. You could fit tens of thousands of galaxies across one of those voids, yet it would still appear almost featureless. Almost, because nothing in the cosmos is truly empty. Even the loneliest corners contain dark matter, quantum fields, and the occasional rogue galaxy sliding through like a lost traveller between cities. There's a historical curiosity here. The first person to speak of cosmic hollowness wasn't a modern astrophysicist, but the 17th century philosopher Blaise Pascal. He wrote of the eternal stallance of these infinite spaces and found it terrifying. He didn't know he was describing what cosmologists would later measure, vast tracts of space where gravity itself seems to have gone thin. Funny how dread can be prophetic. A quirky tidbit. If the universe really is dominated by dark energy, then even these enormous voids might be expanding faster than the rest of space. It's like watching soap bubbles swell within a bigger bubble, each boundary trembling with unseen tension. Some simulations suggest galaxies near void edges are being pushed outward by this imbalance, subtly reshaping cosmic flows. You imagine the Milky Way riding one of those invisible gradients, sliding ever so gently toward the next filament, an intergalactic current you'll never feel, but that defines your place in everything. Back on Earth, this discovery doesn't cause much panic. The morning news still talks about politics and celebrity breakups, not about us possibly floating inside a giant hole, but the implication is quietly radical, and if we inhabit an underdense region, then light from distant galaxies travels through less matter than expected. arriving slightly brighter, slightly bluer, slightly earlier. That could make the universe seem to accelerate more than it truly does. Dark energy, the mysterious force blamed for cosmic expansion, might just be an illusion caused by our unlucky position in a cosmic dip. You stretch this thought out like taffy until it starts to glisten. A universe with no special places suddenly has one. Ours. We'd be in the cosmic equivalent of a cul-de-sac, a low-density bubble in an endless neighbourhood of other bubbles. Maybe that's comforting. We've always liked being in the centre of things. Or maybe it's just funny that humanity, forever trying to escape insignificance, accidentally found itself inside the emptiest region around. Joke's on us. Some astronomers resist the idea. The data, they say, don't quite fit. Supernova measurements, baryon acoustic oscillations, and cosmic microwave background readings all still point to genuine dark energy. Yet even skeptics admit the void hypothesis remains mathematically possible. It's the cosmological equivalent of a good ghost story, unlikely, but you keep the lights on just in case. The night deepens. You picture yourself drifting farther from the Milky Way, its spiral arms curling like faint smoke. The galaxy fades into the black, then into numbers, coordinates, and ratios of mass to nothing. The emptiness swells around you. You realize you can't tell where the edges of the whole begin or end. Perhaps there are none. Perhaps the entire universe is the whole, with thin walls of matter outlining its invisible form. Somewhere a radio telescope hums, mapping the void with patience that borders on poetry. Each data point, each flicker of microwave radiation builds another pixel in our portrait of nothingness. You lean back, listening to the quiet static of the universe, feeling small but also strangely placed, like a single atom aware of the room it's in, and just before your thoughts dissolve completely into the dark, you laugh once, softly, because the cosmic punchline lands at last. The most spacious part of the cosmos, the region so empty it almost doesn't exist, is home. You drift farther into that idea of invisible architecture. The universe is a structure made mostly of things we can't see, shaped by forces we can barely name. Mapping the unseen has always been a kind of cosmic detective work, equal parts math and faith. You picture astronomers staring at faint smears of light through telescopes the size of cathedrals, plotting redshifts, turning those dots into coordinates. One by one, galaxies become data points, and when all the points are connected, something beautiful and eerie emerges, the cosmic web. It's a lattice of filaments and clusters separated by yawning voids, a vast three-dimensional spiderweb where galaxies sparkle like dew. You realize that what looks random from Earth is actually patterned, that the cosmos has bones. To see those bones, scientists rely on light that has traveled for billions of years. The Sloan Digital Sky Survey, for instance, mapped over 1 million galaxies, building a 3D chart of our visible universe. When you zoom out far enough, the picture stops looking like stars and starts looking like neurons. The comparison isn't poetic. The universe truly resembles a brain in its connectivity, filaments glowing where matter concentrates, spaces dim where voids dominate. Historians still argue whether this resemblance means anything, whether the cosmos is a kind of mind reflecting itself, or if humans simply love finding patterns in chaos. Either way, you can't help but feel like you're floating inside a living thought. But how do you map nothing? That's the real trick. The voids don't emit light, they barely bend it. To find them, astronomers study where galaxies aren't. They track brightness distributions, gravitational lensing, and distortions in the cosmic microwave background, the faint radiation left over from the Big Bang. The microwave sky is a near-perfect uniform glow, but tiny fluctuations reveal density differences. Those colder, dimmer spots often point to regions with less matter, the invisible footprints of cosmic hollowness. You imagine it like this. Draw a map of all the bright city lights on Earth at night, then invert it. The dark patches, deserts, oceans, forests would outline our planet's quietest spaces. Now stretch that idea across billions of light years. You'd get the universe's silence charted by its absence of glow. A quirky tidbit. Some of the largest identified voids have nicknames, as if scientists couldn't resist giving the dark a bit of personality. There's the Boötes void, discovered in 1981, so huge it could swallow tens of thousands of Milky Ways. It sits like a cosmic bruise in the constellation Bootes, about 700 million light-years away. If the Milky Way were placed at its centre, you'd have to travel 500 million light years in any direction before bumping into another galaxy. For scale, that's like standing on a beach where the next grain of sand is in another solar system. When the Boötes void was first discovered, it unsettled astronomers. The prevailing models of cosmic structure hadn't yet accounted for such vast emptiness. There shouldn't be gaps this big, one researcher muttered in disbelief. Yet there it was, undeniable, mapped by redshift surveys and confirmed by follow-up telescopes. The universe, it seemed, was not evenly sprinkled with galaxies like sugar on a donut. It was more like a sponge, full of holes. Mapping this sponge requires the patience of saints. Every data set must account for distortion caused by our own movement through space, by gravitational lensing, by the speed of light itself. Even time becomes an accomplice in confusion when you look at a distant galaxy. You're seeing it not as it is now, but as it was billions of years ago. The deeper you look, the younger the universe becomes, and the older the light gets. You're peering into a cosmic scrapbook where every page is a different century of creation. The Milky Way sits inside what astronomers call the local sheet, a flattened region of galaxies forming part of a filament that borders nearby voids. It's like living on the thin crust between bubbles. Surrounding that sheet is the local void, a nearby underdense region that seems to push our galaxy outward. Gravity doesn't only pull, it can also repel, in a way, when there's less mass on one side than the other. That imbalance gives galaxies like ours a slow drift, a cosmic nudge toward denser territory. Historians still argue whether this local void fully explains our galaxy's peculiar motion, or whether deeper attractors, massive superclusters far beyond, are tugging us through space. Some point to the Shapley concentration, one of the most massive structures known, whose gravity may be influencing the entire region. Others think it's a mix of both, pull from above, push from below. Whatever the cause, you can picture the Milky Way sliding along an invisible tide, carried through an ocean of near nothing. It's a funny realization. Most of the universe's structure is actually the absence of it. Matter forms the outlines, but the voids form the shape. It's like sculpting from negative space, Michelangelo chipping away at marble until the emptiness reveals the figure. The galaxies, you realize, are the leftover marble dust. Somewhere deep in your mind, a quiet question flickers. How can we trust what we see if the universe itself is built from things we can't? Every measurement we make is filtered through voids, warped by gravity, stretched by time. Light bends, fades, shifts. Even the background radiation, the oldest signal we can detect, passes through billions of light years of distortion before it reaches us. Our maps might be as much illusion as insight. Still, you can't help admiring the persistence of human curiosity. For all our cosmic ignorance, we've charted more of the universe than of Earth's own oceans. Each new survey, DESI, Euclid, the Vera Rubin Observatory, promises sharper maps of the unseen. We're tracing voids like cartographers sketching sea monsters at the edges of their charts. Here be nothing, they might as well write, though nothing more. It turns out has structure, shape, even motion. You lean back and imagine one of those maps unfurling before you. Clusters bloom like galaxies frozen in fireworks. Filaments thread between them like silk. In the middle of it all, you locate our home, a faint dot adrift in the dim space between luminous strands. A cosmic cul-de-sac again, quietly expanding, quietly ignored. You smile because for once, insignificance feels oddly peaceful, and somewhere light continues to travel, crossing voids, losing energy, becoming redder, older, gentler. It tells the story of a universe always pulling itself apart, yet somehow holding us within its fragile design. You find yourself floating closer now, shrinking the cosmic lens until galaxies fade away, and the familiar glow of our own stars takes over. The vast supervoids melt into something more local, something that surrounds you without you ever noticing, the local bubble. Compared to the great cosmic hollows stretching hundreds of millions of light years, it's tiny, a mere few hundred light years across. But in human terms, it's still a vast, transparent cavern of thin core and memory. You imagine it like a bubble blown into the interstellar medium by a child made of stars. The solar system drifts inside its airy shell, right in the middle, gliding through gas so rarefied that if you scooped a cubic meter of it, you'd find only a handful of atoms. It's emptiness with personality. The story begins, as most cosmic ones do, with something violent. Around 10 to 20 million years ago, a chain of supernovae exploded nearby, massive stars dying in spectacular succession like a cosmic fireworks finale. The shockwaves from those blasts carved out a cavity in the interstellar medium, pushing away dust and gas, heating what remained to a temperature of roughly 1,000,000 degrees Kelvin. The remnants expanded, collided, and gradually cooled, leaving behind the hot, low-density region we call home. Historians still argue whether these supernovae originated in the Scorpius-Centaurus association or in several different star-forming regions, but the evidence is written across the sky. The outer shell of the local bubble glows faintly in soft X-rays, a ghostly fingerprint of ancient explosions. A quirky tidbit: if you could somehow see the local bubble from outside, it might remind you of a balloon squashed in one corner, lumpy and irregular. It isn't a perfect sphere. Cosmic events never are. And oddly enough, it seems to connect to other bubbles, forming a honeycomb of interstellar cavities throughout the Milky Way. The solar system happens to reside near one of the tunnels linking ours to the neighbouring Lupo bubble. You're not in a cosmic cell, you're in an interstellar beehive, sweet empty nectar everywhere. You glance around in imagination. The sun sits near the bubble's centre, while surrounding stars like Alpha Centauri, Sirius and Altair hover close to its edges. Their light travels through unusually clear space. That's why the night sky looks so crisp from Earth. If we lived deep inside a denser cloud of interstellar dust, the stars might shimmer dimly or not at all. In a strange way, those ancient supernovae gave you the gift of visibility. They cleared the local fog, giving the Milky Way's lights a chance to reach your sleepy eyes. There's a particular satisfaction in knowing that our solar system's address has such dramatic origins. You're sitting on a planet that was formed inside a nebula, which sits inside a bubble, which floats inside a spiral arm, which drifts inside a galaxy, which itself glides through a cosmic void. Layers within layers, like Russian nesting dolls, but with more radiation poisoning. You chuckle softly at the thought. The universe really loves its metaphors. Researchers recently confirmed the local bubble's outline using data from the Gaia satellite, which tracks the positions and motions of more than 1 billion stars. By plotting young stellar nurseries and the trajectories of expanding gas shells, astronomers could literally trace where the explosions happened and how they sculpted the cavity. It's like reconstructing a crime scene where the suspects exploded long ago. From that reconstruction, they discovered that most nearby star-forming regions, the Orion Nebula, Perseus, Taurus, sit right along the bubble's rim. The implication? Those supernovae didn't just clear space. They triggered new generations of stars, compressing gas along the boundary until gravity took over. In a sense, our sun's ancient neighbours died so that future suns could live. Historians still argue whether the local bubble is still expanding. Some measurements hint at a slow outward motion of its walls, others suggest it's stabilised, balanced by surrounding clouds. Either way, we're safe inside for now. The boundary lies dozens of light years away, like the invisible walls of a cosmic fishbowl. Every time the solar system drifts a little, it swims through slightly different densities of gas. The heliosphere, our sun's magnetic bubble, puffs and shrinks in response, a bubble inside a bubble inside a bubble. You get dizzy just thinking about how many layers of protection separate you from absolute nothingness. On Earth, we sometimes forget that we're passengers inside this invisible structure. Our radio telescopes pick up faint X-rays and ultraviolet glimmers that betray the bubble's hot gas, but to the naked eye, space looks smooth. You might look up at the Milky Way and think the dark gaps between its stars are empty. They're not. They're part of a delicate, invisible architecture shaped by ancient cataclysms. Even the night you see is a memory of violence long cooled into peace. There's something beautifully ironic in that. The same blast that destroyed entire star systems also cleared the way for your quiet nights. Without those explosions, the dust around here might have stayed thick enough to smother sunlight before it reached forming planets. Maybe Earth wouldn't have warmed properly. Maybe life wouldn't have stirred. It's one of those cosmic jokes that sound philosophical until you remember it's literally just physics. But still, thank you. Sir, woo? Exploding stars. The local bubble also affects how astronomers read the universe. Because it's filled with hot plasma that emits X-rays, it adds a faint foreground glow to many observations. Scientists have to subtract that interference to study distant galaxies accurately. In a way, our home bubble is photobombing our view of the cosmos. Smile, you imagine it saying, "You're inside me." You can't decide whether that's comforting or horrifying. Probably both. A favourite historical moment comes from the late 1970s, when researchers first detected the bubble through soft X-ray observations and couldn't quite believe it. Some suspected instrumental errors. Others thought it was evidence of a new kind of cosmic radiation. It took years to accept that the simplest explanation, a local cavity carved by supernovae, was right. It's a good reminder that even scientists sometimes struggle with emptiness. We tend to trust what we can see, but the universe keeps insisting that what's missing matters more. You let that idea settle, you live inside the residue of destruction, bathed in gentle radiation from dead suns, breathing on a planet that orbits through a space made safe by ancient chaos. It's both humbling and strangely cozy. Like realizing your home was built from the ashes of a long-forgotten fire, yet the walls still glow faintly with its warmth. You take one last imaginary look around the local bubble, its edges glowing softly in X-ray light, its center quiet, your sun drifting peacefully, and feel a flicker of gratitude toward those long-gone supernovae. They blew the dust away so you could see the stars. That's the universe's version of house cleaning. You drift outward again, zooming the scale from our little interstellar cocoon to the titanic tapestry that holds every galaxy you've ever heard of, and billions you never will. The cosmic web stretches around you like a three-dimensional lace of light and shadow, its filaments glowing faintly with the collective shimmer of galaxies and the soft hum of dark matter. You're not just seeing space, you're seeing structure, the skeleton of everything. Between those glittering threads are the voids, vast pockets of near-nothingness that dominate the universe's volume. It's funny, you think, how the emptiness takes up more room than the substance. The universe isn't so much a collection of things as a collection of spaces between things. The story of how astronomers discovered that structure feels almost cinematic. In the late 20th century, when the first large-scale galaxy surveys began, scientists expected galaxies to be more or less evenly distributed. After all, shouldn't gravity and expansion scatter matter smoothly across the cosmos? But as maps grew denser, patterns emerged. Walls, filaments, and gaps that resembled the cross-section of a sponge. In 1989, Margaret Geller and John Huckra's CFA Redshift survey unveiled what looked like a colossal sheet of galaxies, the Great Wall, stretching hundreds of millions of light-years across. That single discovery proved that the universe wasn't a random sprinkle of matter, it had texture. Historians still argue whether Geller's wall counts as one structure or the chain of connected ones, but the message was clear. Cosmic architecture exists, and we're inside it. You picture yourself shrinking and expanding simultaneously, small enough to grasp a single galaxy, large enough to comprehend the pattern. The filaments look like veins carrying matter instead of blood. The voids between them are cells of vacuum. You float through one of those threads, brushing past clusters where galaxies huddle together, like cities linked by the intergalactic highways. Each intersection glows with the heat of 1 trillion suns. Between those intersections, the filaments stretch thin, tapering into emptiness, until you slip again into the silence of a void. The transition is so smooth that you hardly notice the moment when light becomes rare. Here's a quirky tidbit. Simulations suggest that these filaments might not just guide galaxies, they might guide galaxy spins. Some data hint that spiral galaxies align their axes with the filaments they inhabit, like iron filings following a magnetic field. Historians still argue whether this alignment is coincidence or a deep physical consequence of how angular momentum emerged in the early universe. Either way, the idea that entire galaxies could know the direction of their cosmic highways feels strangely poetic. Even the universe, it seems, enjoys a bit of traffic organization. You glide along one of these filaments and realize how thinly matter is spread. Even in the densest clusters, space is mostly empty. Billions of kilometers between stars, millions between galaxies. The bright strands you see in renderings are misleading exaggerations. If you were actually there, everything would look dark. Light would be distant, soft, and intermittent, like lanterns hung across the world's longest desert. You'd feel alone but never lonely, because this solitude is shared by everything. Gravity, the sculptor of all this, works like an artist obsessed with contrast. Matter attracts matter, leaving gaps where it isn't. Over billions of years, those gaps grew larger as the universe expanded and the matter condensed along the edges. But it's not unlike red rising, dense pockets forming where dough sticks together, air pockets stretching between. The cosmic loaf, one cosmologist once joked, except you can't eat it and it's 93 billion light years wide. You snort softly at the thought. Even physicists can't resist bad baking metaphors. But behind the humour there's awe. These filaments and voids tell the story of how gravity, dark matter, and cosmic expansion have been arguing since the dawn of time. Dark matter wants to pull everything inward. Dark energy wants to push it apart. The cosmic web is their uneasy compromise, a network stretched taut between attraction and repulsion. Without dark matter, no filaments would have formed, galaxies would have drifted too far to clump. Without dark energy, the web would have collapsed under its own gravity long ago. The result is a dynamic balance, as though the universe keeps breathing in and out, inhaling structure and exhaling emptiness. You recall that even the largest known structures, the Hercules Corona Borealis Great Wall for instance, span more than 10 billion light years. Some astronomers argue that such vastness breaks the cosmological principle, the idea that the universe should look roughly the same in all directions and locations. Historians still argue whether these megastructures are truly single entities or just chance alignments of smaller walls, but you can't help feeling like the universe is testing its own rules, quietly cheating on uniformity. There's an odd serenity in realizing that these massive formations exist, yet we'll never see them as they are now. Light takes so long to reach us that every observation is a fossil. When you look at a distant filament, you're not seeing the current universe. You're looking billions of years into its adolescence. It's like opening an old diary written in photons. You imagine the universe blushing at its old handwriting. The deeper you drift, the more you sense that filaments and voids are partners in a grand choreography. Where one grows thick, the other stretches thin. Matter flows along gravitational gradients, draining from voids into filaments like rivers feeding an ocean. It's this movement, slow and relentless, that built the galaxies and clusters we now map. You right now are part of that flow. The atoms in your body were once part of a gas cloud sliding down a filament's invisible slope. Every breath you take carries the rhythm of cosmic migration. Another fun fact, scientists have even simulated how galaxies fall into these filaments, forming bridges between clusters. The Millennium simulation, one of the largest of its kind, showed the cosmic web evolving over 13 billion years. Watching those simulations is hypnotic. Knots forming, filaments stretching, voids deepening. It's like watching time-lapse footage of the universe growing its own nervous system. And here you are, a single neuron firing inside it, asking questions about the brain that contains you. You pause there, somewhere between science and reverence. The cosmic web isn't just a structure. It's an idea that everything connects, even through nothingness. You picture those invisible filaments threading not only galaxies but thoughts, histories, moments. Every connection, gravitational or human, is a filament of its own. The spaces between us might be the true architecture of meaning. And just as that thought begins to fade, the scene around you changes again. The filaments thin into fog, the galaxies drift apart, and you begin to feel the pull of deeper emptiness ahead. The beginning of the void's true empire. You feel yourself slipping from awe into argument, because every great cosmic mystery seems to spark one, and tonight's debate is a big one. You're eavesdropping on a quiet yet passionate quarrel echoing through observatories and conference halls, the question of what these vast cosmic voids mean. Specifically, whether the emptiness could actually trick us into thinking the universe is expanding faster than it really is. It's called the Great Nothing debate, and the stakes are nothing less than the reality of dark energy itself. You hover in the dark between galaxies and listen as centuries of curiosity turn into speculation and math. The scene starts in the late 90s, when astronomers measuring distant Type Ia supernovae discovered that those explosions appeared dimmer than expected. Dimmer meant farther, and farther meant the universe was expanding faster than predicted. It was the birth of dark energy, the mysterious force that supposedly drives cosmic acceleration. But even back then, a few stubborn minds whispered, what if we're simply misreading the map? If we happen to live inside a large underdense region, a cosmic void, then the light from distant galaxies would have to cross that emptier space. experiencing less gravitational slowing on its journey. The result? It would reach us slightly fainter, slightly delayed, creating the illusion of acceleration where none exists. Historians still argue whether this void mimicry could actually explain the data. Early models, like the Lemaitre-Tolman-Bondi metric, tried to show that a universe without dark energy could reproduce the same observed expansion curve if we were situated near the center of a supervoid hundreds of millions of light-years wide. But it required a kind of cosmic coincidence that made many cosmologists squirm. Why us? Why here? It sounded a bit too much like the old geocentric universe, the one we thought we'd outgrown. The irony, of course, is delicious. After centuries of insisting we're not special, maybe the math was suggesting otherwise again. You imagine the debate like a friendly chess match under starlight. On one side, the voidists, arguing that cosmic structure could distort our perspective. On the other, the dark energy defenders, insisting the data from supernovae, cosmic microwave background, and baryon acoustic oscillations all point to a real, universal acceleration. Both camps stare at the same sky, both with impeccable math, both convinced the other side is missing something obvious. It's like watching two people argue, whether a glass is half empty or half full, while floating inside the glass itself. A quirky tidbit. In 2013, a study using the KBC void model proposed that our Milky Way might indeed sit near the centre of a vast underdense region about 2 billion light-years across. It even seemed to explain part of the infamous Hubble tension, the discrepancy between the local and cosmic measurements of the universe's expansion rate. But later data from the Planck satellite and larger surveys complicated that neat picture. The void exists, yes, but probably not large or deep enough to replace dark energy entirely. In short, the void hypothesis didn't collapse, it just got lonelier. You drift through that loneliness now, picturing the universe as a theatre, every observation a play performed for your limited viewpoint. Light travels across billions of years, weaving through clumps of matter and stretches of emptiness subtly distorted by each. By the time it reaches your eyes or telescope lenses, it's carrying not a snapshot but a long exposure of reality, layered and warped. So when scientists say the universe is expanding, what they really mean is that the light arriving here tells a consistent story, consistent enough that even alternative models must bend toward it. Still, the beauty of science lies in that very argument. Historians still argue whether Einstein's cosmological constant, the original fudge factor he introduced, then abandoned, should be seen as a primitive version of dark energy or as something else entirely. Each new measurement nudges the conversation forward but never closes it. You imagine Einstein watching from beyond, smirking softly as his once discarded idea becomes the century's biggest mystery. Maybe he'd sip cosmic coffee and whisper, "Told you not to get too comfortable with nothing." You start to see how the void debate reflects something deeper in human nature. We're uneasy with absence. We prefer substance, explanations, forces, and causes. The concept that emptiness itself might shape our observations feels too passive, but physics doesn't care about our preferences. Gravity and geometry can conspire to make emptiness an active participant. Inside a large void, space expands faster than in denser regions. Less gravity means less resistance. Over time, that extra expansion exaggerates the contrast between inside and outside, amplifying the illusion of cosmic acceleration. The universe could be playing a long, quiet trick on its observers. And here's the kicker. Even if we aren't inside a grand enough void to explain dark energy, smaller voids still affect what we see. Light passing through them gets slightly stretched, redshifted by the faster expansion within. This so-called integrated Sachs-Wolf effect leaves faint fingerprints on the cosmic microwave background, tiny patches where the afterglow of the Big Bang looks cooler or warmer than average. The cold spots, some say, might even mark enormous voids yet unmapped. Others argue they're statistical flukes. Historians still argue, of course, because arguing is the heartbeat of discovery. You drift through that imagined cold spot, the emptiness almost tactile. There's no up or down here, only perspective. The galaxies on the far side look slightly magnified, their light stretched and tinted by the geometry of space. It feels absurd to realize that nothing can act like a lens, bending light just by being less than average. But that's the universe for you, the absence of matter behaving like matter's shadow puppet. A faint smile tugs at you. Maybe dark energy is real. Maybe it's a vacuum property, a kind of cosmic pressure pushing on space-time itself. Or maybe it's just the universe's way of reminding us that every measurement depends on where we stand. The only certainty is that nothing remains the most powerful something we know. You remember that centuries ago, philosophers debated whether a vacuum could even exist. Aristotle insisted nature abhors it. Newton imagined invisible forces acting through it. Now we map it, quantify it, argue over it. We've come a long way just to admit that the universe might in the end be mostly empty, and that the emptiness itself might be running the show, as the lights of distant galaxies flicker like arguments cooling into silence. You find yourself drifting again toward the next question. If nothingness can deceive us, what else can it do? The debate fades behind you like the static of a late-night radio station, replaced by something slower, softer, light itself stretching across the dark, and you imagine a single photon leaving a distant galaxy billions of years ago, small and defiant, beginning a marathon through emptiness. It races through clusters, slips between filaments, glides across voids where matter thins to nearly nothing. There, in the silence of true cosmic isolation, something strange happens. The photon begins to change. Not because it's tired, photons don't age the way you do, but because the very space it's crossing is stretching beneath it. Each heartbeat of cosmic expansion lengthens its wavelength, turning blue light to red, red to infrared, until eventually the photon drifts into invisibility. Light, you realize, moves through the universe in slow motion, not because it slows down, but because space won't stop growing around it. Astronomers call this phenomenon cosmological redshift. You call it patience made visible. Every galaxy's light carries its own timestamp, its own record of how far the universe has stretched since that photon began travelling. When scientists talk about looking back in time, they mean this literally. The farther the light, the older the story. That faint glow you see through a telescope tonight might have begun its journey when dinosaurs ruled the Earth, or long before Earth even existed. And between its origin and you lies a whole ocean of voids. Light crosses them like a message in a bottle thrown into an expanding sea. Historians still argue whether the redshift is best understood as light losing energy or as space itself elongating. The math supports the latter, but the imagery of tired light has persisted for decades, charmingly wrong yet poetically irresistible. You picture photons yawning as they pass through endless darkness, complaining about the cosmic commute. Maybe that's why the night sky looks sleepy. Here's a quirky tidbit. When the light from the most distant quasars finally reaches Earth, it has been stretched so much that what once burned in ultraviolet now arrives as radio waves. The universe has literally remixed its own soundtrack. You could say every photon is a cosmic DJ, slowing down the beat as it moves through space-time. Somewhere in that distortion lies the ultimate proof of cosmic expansion, the music of the void. As you drift deeper into that metaphor, you realize that light doesn't just mark distance, it feels the structure of the universe as it travels. When it passes through dense regions, gravity tugs at it, making it lose a little energy climbing out. When it crosses a void, it gains some back, but not as much as it lost. The net result is a faint redshift that encodes the cosmic landscape. Astronomers can, in theory, read that pattern like Braille, tracing where the voids and filaments lie just by measuring the subtle bruises left on light. It's a quiet revelation. The universe writes its autobiography in the language of photons. You wonder what that means for perception. When you gaze up at the Milky Way, you're not seeing the present. You're seeing a layered collage of different pasts, some stars seconds old, some thousands, some millions. The further you look, the older the light. Even the blackness between stars isn't empty. It's filled with a radiation so faint that only specialized instruments can catch it. That radiation, the cosmic microwave background, is the oldest light of all, frozen from when the universe was just 380,000 years old. It's so ancient that every photon has been stretched 1,000-fold, turned from brilliant white-hot plasma into a whisper of microwaves barely above absolute zero. Yet those whispers are everywhere. You're literally bathed in the afterglow of creation right now. Historians still argue whether that microwave background is perfectly uniform or subtly skewed by voids and clusters along its path. The integrated Sachs-Wolf effect. Remember that faint temperature shift caused by light passing through varying gravitational potentials? is one way we know the universe's large-scale structure affects even this oldest light. It's almost comforting. Even the relic glow of the Big Bang hasn't been able to escape the universe's meddling. You imagine yourself following one of those photons from its birth to your eye. At first, it's a blinding pulse escaping the primordial plasma, bouncing off atoms like a child learning to walk. Then as the universe expands, collisions become rare. The photon finally roams free. It travels for billions of years, crossing galaxies, weaving through invisible threads of dark matter, slipping through voids so empty it could flow for 100 million years without encountering a single particle. Somewhere along the way, it becomes weaker, older, gentler, and then, one night, it touches the sensor of a telescope or maybe the back of your retina, and the universe whispers, "You made it." You think about that. The faintest star you see has survived a journey of unimaginable length just to die inside your eye. Romantic in a melancholy sort of way. A fun historical note: Edwin Hubble's first measurements of the galactic redshifts in the 1920s were so rough that he underestimated distances by a factor of 10, yet his discovery that galaxies farther away recede faster was revolutionary. It gave birth to the concept of an expanding universe. Historians still argue whether Hubble truly understood the implications, or if he was simply too cautious to claim them outright. Either way, that single correlation between distance and redshift rewrote our cosmic story. It's the reason we even know there's a cosmic void to discuss. In your mind's eye, you watch the universe breathing, light stretching as space expands. The wavelengths pulsing like a slow heartbeat. Redshift is the soundless sigh of time itself. Every colour in the cosmos is a timestamp, and every shade of red is another measure of distance between now and then. You wonder if that's why sunsets feel so profound. Your eyes are trained by the universe to find meaning in stretched light. Somewhere beyond the farthest galaxies, the photons keep going. They'll pass our descendants, our telescopes, even the eventual ruins of our civilization, continuing their journey through expanding space until they fade into wavelengths longer than the size of the universe itself. That's what light in slow motion really means. Not fatigue, but persistence. The universe keeps stretching the story and light keeps telling it, one elongating breath at a time. And as you float there, surrounded by invisible colour, you realise that to watch light move through nothing is to watch time. Learn how to age. You drift deeper into the hush, following that idea of stretched light until it leads you to a single blemish on the universe's otherwise smooth skin, the cold spot. It sits like a bruise on the cosmic microwave background, a region of sky slightly cooler than its surroundings, wide enough to swallow entire constellations. Discovered in the early 2000s by the WMAP satellite and later confirmed by Planck, it quickly became one of cosmology's favourite mysteries. Why should one patch of the Big Bang's afterglow be a few hundred microkelvins colder than the rest? The difference is tiny, yet over such vast scales, it shouldn't exist at all. You hover before it now, staring into the faint shadow of something older than galaxies, wondering whether you're looking at the fingerprint of an enormous cosmic void, or the scar of something stranger. The first explanation, naturally, was mundane, a random statistical fluke. The universe, after all, is messy, patterns appear by chance. But then came the supervoid hypothesis. Astronomers scanning that region of the sky found fewer galaxies than expected, suggesting a vast underdense region stretching nearly 2 billion light-years across, centred in the constellation Eridanus. That's not just a void, it's a cosmic canyon. If true, the light from the early universe would have travelled through that region, losing a bit of energy as it passed. When it finally reached us, it would appear cooler, a phenomenon known as the integrated Sachs-Wolf effect. The math fits nicely, the story fits beautifully. Historians still argue, though, whether the void is big enough to cause such a deep chill. Some say it would have to be impossibly vast. Others whisper that perhaps several voids overlap there, forming a kind of cosmic super gap. You imagine what it would feel like to float inside that emptiness. A billion light-year desert where galaxies thin to nothing, where the silence isn't just the absence of sound but the absence of structure. The night would be darker, the distances crueler. If you shone a flashlight, it would travel forever without reflection, swallowed by distance itself. The mind resists that kind of scale. You try to picture it, and your imagination quietly gives up halfway through. It's like trying to dream about nothing. A quirky tidbit. When scientists first announced the cold spot Kopo, tabloids briefly ran with headlines claiming it might be evidence of a collision with another universe. The logic, if you can call it that, was that only something beyond our cosmic horizon could imprint such a large anomaly. The idea still lingers in theoretical circles. Maybe our universe once bumped into a neighbouring one in the multiverse, leaving a bruise on the cosmic background. It's an enticing thought, universes like soap bubbles colliding gently in an endless cosmic foam. But even those who love the theory admit it's speculative at best. Historians still argue whether invoking another universe to explain a temperature blip is brilliant or desperate. Probably both. You hover there, watching the faint microwave glow shimmer like ancient embers. The cold spot isn't empty in a literal sense. It's filled with radiation, faint galaxies, and dark matter. But compared to the cosmic average, it's underwhelming. A little quieter, a little thinner. You feel as though the universe took a deep breath there and never quite exhaled. The Planck satellite's detailed maps deepened the mystery rather than solving it. Yes, the cold spot is real. No, it's not a mere artifact of data, but its exact cause remains uncertain. The observed supervoid along the same line of sight seems too small and too shallow to account for the full anomaly. Some cosmologists shrug and call it coincidence. Others lean forward in their chairs, convinced that coincidence is just another word for undiscovered physics. You like that second group, they're the dreamers, the ones who see patterns even in silence. Here's the funny part. Even if the cold spot is just a statistical oddity, it still tells us something profound about human curiosity. We built satellites capable of measuring temperature variations of a few millionths of a degree across the entire sky. We noticed a patch slightly off pattern and collectively lost sleep over it for 20 years. That's the kind of obsession that makes science both maddening and beautiful. You can almost hear the universe chuckling, "Really? You found my one imperfect pixel?" Floating through this region in imagination, you realize how light behaves differently inside such emptiness. There's less gravitational tug, fewer galaxies to deflect or absorb it. Photons sail more freely, but the trade-off is loneliness. They travel farther between interactions, aging in isolation. The cold spot might just be a monument to that solitude, a stretch of cosmic road where light travels without company. You feel a pang of empathy for those photons, if that's possible. They've been journeying for 13 billion years just to be a little colder than average. There's also an aesthetic pleasure in the phrase itself, cold spot. It sounds like a place you could visit, a destination for cosmic wanderers. Next stop, the Eridanus cold spot, bring a sweater. You chuckle softly, because humour seems to be the only human defence against scales this large. Then, as your smile fades, another thought takes shape. Maybe the cold spot isn't an anomaly at all. Maybe it's a hint that our assumptions about uniformity are wrong, that the universe has more personality than we give it credit for. Historians still argue whether the cosmic microwave background really proves the universe is isotropic, identical in all directions, or whether small asymmetries, like this one, reveal deeper truths. Some say the cold spot could point to early quantum fluctuations amplified by inflation. Others see in it the ghost of long-dead cosmic strings, those hypothetical filaments of primordial energy left over from the universe's birth. Either way, it stands as a reminder that even the most ancient light still carries secrets. You stare into that faint, chill patch until your thoughts begin to slow. The cold spot becomes less of a riddle and more of a feeling, a subtle awareness of distance, of time stretched thin. Maybe the universe isn't perfectly smooth because perfection would be too dull. Maybe it needs small scars to make its vastness interesting. And just as that thought settles, you start to drift again. Away from the chill, away from the debate, toward the earliest storytellers who tried to explain the dark without telescopes or data, only wonder. You surface from the cold spot's glacial quiet and find yourself drifting through a more ancient kind of cosmos. Not one mapped by satellites, but one imagined in firelight and chiseled into stone. Long before anyone could whisper microwave background, people were already peering into the dark and wondering what lived there. Tonight, you visit those first skywatchers, the stargazers who looked up at the void and filled it with gods. You hover above deserts, jungles, islands, and mountains, watching humanity try to make sense of the same emptiness you've just crossed. In ancient Egypt, priests of Ra tracked the sun's daily voyage through the sky and into the underworld. Night wasn't merely the absence of light, It was a dangerous tunnel, the cosmic equivalent of a void. Every sunset was a descent into chaos, every sunrise a victorious rebirth. The sky goddess Nut was sometimes drawn as a giant arching body filled with stars, swallowing the sun each evening and birthing it again by dawn. Historians still argue whether these myths encoded actual astronomical observations, like the heliacal rising of Sirius, or whether they were purely spiritual metaphors. Either way, you smile. They were grappling with cosmic structure long before redshift diagrams existed. A quirky tidbit. Egyptian cosmetics were partly practical astronomy. The black coals smeared around their eyes didn't just look regal. It reduced glare from the desert sun, improving visibility during daylight sky readings. It turns out to map heaven properly, you needed good eyeliner. You file that under science by style. Far to the east, the Babylonians built their ziggurats as stairways between earth and sky. They treated constellations as divine writing, cosmic cuneiform marking the boundary between order and the void. You picture an astronomer atop one of those temples, measuring the rising of Venus against the horizon, unaware that he's contributing to what will become the world's first recorded scientific data. Even then, humans were turning the mystery of nothingness into calendars, omens, and equations. Then you leap to the Mayan world, where the Milky Way was seen as a great celestial river. A dark rift running through its center represented the path to the underworld, Xibalba. To them, that black lane wasn't emptiness, but a portal. They built temples aligned with its seasonal position, timing rituals to moments when the mouth of the rift opened overhead. When you look up tonight and trace that same dark stripe, you realize you're seeing the same emptiness, only now you call it interstellar dust. The language changes, but the wonder doesn't. You wander next into the Greco-Roman world, where philosophers began the dangerous business of arguing with myth. Aristotle famously declared that a true void could not exist. Nature, he said, abhorred it. Centuries later, Epicurus and his student Lucretius rebelled, insisting that atoms drift through infinite empty space, colliding, combining, creating worlds. Historians still argue whether their atomic model was a lucky guess or a profound insight glimpsed through intuition. Either way, their version of the universe, matter dancing through void, sounds suspiciously modern. You'd almost think they owned telescopes. A quirky aside, Lucretius described the creation of the world as a rain of atoms swirling into vortices. It's not far from how cosmologists now describe the early universe, with matter condensing into filaments and galaxies. The poetic guesswork of a Roman poet foreshadowed the math of general relativity by 2,000 years. Somewhere, Lucretius is probably smirking. You drift toward the east again, to ancient China, where astronomers kept meticulous records of guest stars, what we now know were supernovae. Their oldest preserved observation, from 185 CE, describes a bright new star that lingered in the sky for 8 months. They believed it was a celestial omen, a sign from the heavens. What they didn't know was that this explosion carved out one of the bubbles that would later merge into the great cavities you've been exploring. The link between mythology and astrophysics folds in on itself like a Mobius strip. Humans look up, interpret, and unknowingly record the physics that will one day explain their own stories. Then in the Pacific, you see the Polynesian navigators, masters of night sky geometry. They crossed thousands of miles of ocean guided by nothing more than stars and waves. Their star maps were memorized, sung, and danced. To them, the black space between constellations wasn't frightening, it was guidance. The absence of light marked direction, a negative map etched in memory. Historians still argue whether Polynesian navigation predated written astronomy elsewhere, but everyone agrees it treated emptiness as information, not fear. You pause there, realizing how much cultural gravity the void has always had. In myth, it's chaos. In philosophy, it's the first principle. In physics, it's still the ultimate unknown. The difference is language. The feeling is the same. When ancient people stared into the dark, they didn't see absence. They saw a mirror reflecting their own need for meaning. A gentle thought crosses your mind. Maybe that's why modern cosmology feels like both science and religion at once. We peer into voids for data, but secretly we're still hoping for revelation. You can almost hear the old voices whispering through telescopes. The stars are gods. The darkness is the ocean between them, and you, tiny you, are the sailor. You grin at the continuity of it all. Somewhere an astrophysicist runs code on a supercomputer to model void evolution, and somewhere else a child lies in a backyard tracing shapes in the dark with sticky fingers. Both are doing the same thing, trying to draw meaning on the surface of nothing. A last curious note: even Stonehenge, that ancient ring of stones on the English plain, may have been an observatory of light and shadow, a calendar built from absence. The gaps between stones mark the rising and setting of the sun. It was, in a literal sense, a monument to the void. As the night around you deepens, you realise that every human story about the sky has been a love letter to the dark. Whether it's the void between stars or the emptiness between thoughts, we've always filled it with our own light. You drift higher, leaving behind temples, pyramids, and stone circles, until the myths fade into the cosmic hum again. The ancient sky dissolves into data, and you feel the familiar pull of modern emptiness, the infinite fractal void waiting ahead. The myths fade to static, and you rise again through the layers of night until you can see the cosmic web unfolding below like lacework stretched to infinity. Now, though, your eyes start to notice something stranger. The voids, the empty spaces you thought were gaps between filaments, aren't just gaps. They're structured too, nested like soap bubbles in a sink full of foam. Inside each void, smaller voids form, and within those, tinier still. It's a hierarchy of absence, an architecture of nothingness. You drift among these invisible chambers, realizing that the universe doesn't merely contain emptiness, it organizes it. Cosmologists call this pattern hierarchical voiding. The large-scale structure of the universe isn't just galaxies forming along filaments, but voids clustering and merging into supervoids. It's the cosmic version of the negative space sculpting itself. The smaller voids coalesce, expanding and pushing matter to the edges until they form colossal cavities. Historians still argue whether this process will continue forever, or if the universe will eventually smooth out, leaving no structure at all. You picture the voids as soap bubbles colliding, merging into bigger and thinner membranes until only one grand emptiness remains. That's what cosmological expansion might look like from inside, the universe learning how to breathe itself apart. A quirky tidbit. The patterns created by these nested voids follow the same kind of mathematical fractal geometry you see in coastlines, clouds, and cauliflower. The void boundaries can be described by similar scaling laws, meaning the universe's structure looks statistically the same at different magnifications. Zoom in or out far enough and it repeats itself. The cosmos, it turns out, may be the most elaborate Russian doll ever conceived, only this one hides nothing inside nothing inside nothing. You drift through a cluster of these smaller voids, each one a dim pocket of diluted hydrogen and dark matter. The edges shimmer faintly where galaxies form along the borders, like dew outlining invisible bubbles. You can almost feel the tension between them, a slow gravitational push and pull that has been shaping the universe since its infancy. The smaller voids, called mini-voids, constantly merge and rearrange, forming a shifting foam that evolves over billions of years. It's strange to realize that emptiness is dynamic, alive with subtle movement. Even nothingness refuses to sit still. Cosmological simulations visualize this dance beautifully. You remember seeing one, the Millennium Simulation again, or maybe Illustris, where the camera swooped through billions of years of evolution in seconds. First came the uniform mist of matter, then clumps, filaments, walls, and finally the growing black cavities between them. Watching it felt hypnotic, like bubbles coalescing in slow motion. Some researchers even describe the large-scale universe as cosmic froth. Historians still argue whether this frothiness implies fractal self-similarity all the way down, or whether it smooths out at the largest scales. You can't help smiling. The universe might be infinite, and we're still arguing about whether it's lumpy. You pass through a junction where several voids meet, their boundaries gently flexing under gravity's invisible hand. It feels delicate, like standing inside the surface tension of a soap bubble large enough to hold galaxies. Matter collects at these intersections, forming filaments that connect superclusters. The spaces between, these hollow cells, expand faster than the rest because with less gravity pulling inward, there's less to resist the universal stretch. That's why the voids grow. The denser regions collapse inward, while the emptier ones balloon outward. The result is this shimmering network, filaments tightening, voids blooming, a a cosmic heartbeat of expansion and release, there's an odd comfort in realizing that nothingness behaves so predictably. Even chaos has rules. The bubbles collide, merge, and reshape themselves in elegant mathematical ways. You think of it like cosmic breathing: inhale, exhale, structure, emptiness, structure again. The average density of the universe may drop, but the geometry keeps rhythm. You feel that rhythm pulsing through you, the steady thrum of existence making room for more existence. A fun historical note. The term cosmic foam was first coined in the 1970s, when astronomers noticed the filamentary arrangement of galaxies in redshift surveys. They described it as a frothy structure, with galaxies lining the edges of giant voids. Back then, computing power was limited, so those early maps looked like primitive pointillist paintings, dots on paper hinting at something vast. Now with supercomputers, we can trace the foam in 3 dimensions, the voids stretch like cells in a growing organism. You half expect to see the universe blink. There's also something profoundly philosophical about this fractal void hierarchy. If every void contains smaller voids, and every bubble expands, then there's no clear center, no privileged point in space. Each region feels like the middle because locally it is. You can never step outside the pattern to see its edge, because there may not be one. The more you zoom out, the more the structure repeats itself until your sense of skiddle dissolves. The void doesn't just surround galaxies, it surrounds thought. Historians still argue whether this fractal nature stops at a certain size, but part of you hopes it doesn't. There's poetry in infinite recursion, the same comfort you find in mirrors facing each other, an endless corridor of reflection leading nowhere. The universe's self-portrait, repeating itself to infinity, a pattern of absence pretending to be structure. As you drift deeper into the nested voids, you start to feel small in a new way. Not crushed by immensity, but expanded by it. You're not separate from this pattern, you're one of its ripples. The same physical laws that govern the shape of these bubbles govern the atoms in your lungs. Every breath mirrors the expansion of space. Every pause mimics the stillness between filaments. The void isn't far away, it's what you're made of. You let that realization linger, that nothingness isn't the opposite of being, but its foundation. Without emptiness, there would be no room for stars, no space for galaxies, no silence for thought. The void isn't an absence, it's the stage on which everything performs. And just as that understanding begins to settle, the edges of perception shimmer again. The faint glow of galaxies at the boundaries starts to pulse. You sense something moving inside the emptiness, a flicker of life, or maybe just the loneliness of distant worlds calling through the foam. The next chapter of the void begins to form, the story of those rare galaxies stranded in isolation, burning quietly against the dark. You move through the silent corridors of the cosmic foam until the boundaries sharpen, and there, like faint lanterns scattered across an endless sea, you spot them, the lonely galaxies. They're rare, fragile islands of light adrift inside the voids, hundreds of millions of light years from any cluster. You draw closer to one, its spiral arms curling with quiet defiance, the only beacon for unimaginable distances. The galaxy seems aware of its solitude, as if it burns brighter just to prove that isolation can still create beauty. You hover near it, feeling that paradox, the fullness of something existing in almost nothing. Astronomers call these systems void galaxies, and they're among the most fascinating rebels of the cosmos. Where most galaxies form along filaments or cluster near dense regions, these drift in the hollows between, sometimes alone, sometimes in small scattered families. Historians still argue whether they were born there or exiled, whether the voids created them or whether they're survivors of ancient gravitational battles flung outward during the universe's chaotic youth. Either way, they are cosmic introverts, evolving differently from their crowded cousins. A quirky tidbit, one of the best studied examples, called MCG 10202015, a name only an astronomer could love, sits about 300 million light-years away inside a void. It's modest in size but astonishingly blue, a sign of ongoing star formation. You'd think a galaxy in isolation would run out of gas, yet somehow it keeps forming new suns. It's like a town in the middle of the desert that never stops building streetlights. Some researchers think that being alone shields these galaxies from disruptive interactions. They evolve more slowly, gracefully, like wine aging without disturbance. You drift alongside that quiet galaxy and notice its shape. It isn't perfect, slightly lopsided, one arm thicker than the other, but that imperfection feels earned. Without the gravitational bullying of nearby galaxies, it's free to keep its gas, to spin lazily without being torn apart. The stars here are younger, bluer, and more naive, burning brightly in defiance of cosmic neglect. You realize that in its isolation, this galaxy has achieved something almost enviable: peace. But peace doesn't mean stasis. Even here, gravity is patient. Over billions of years, the void itself expands, and this galaxy, though motionless relative to its neighbours, is being carried outward by the universe's relentless breath. You imagine watching from some hypothetical ship in orbit, witnessing a galaxy slowly receding from everything, its light growing fainter, redder, older. It's cosmic solitude on a scale too vast for human melancholy, yet you feel it anyway. The quiet is so complete it hums. Historians still argue whether void galaxies offer clues about the early universe's conditions. Some think they're fossils, unchanged remnants from a simpler epoch when matter first began to clump. Others argue they're laboratories of pure evolution, untouched by the chaos of mergers and collisions. In the dense cosmic city centres, galaxies constantly smash together, cannibalize each other, ignite bursts of star formation, and then fade. But here in the void, time moves differently. You could watch 1 billion years pass and see almost nothing change. Stillness becomes the story. A fun historical note: in 1987, astronomers discovered that the Bootes void, the same colossal cavity you learned about earlier, contains about 60 galaxies scattered throughout its vast interior. 60, in a space that could easily hold tens of thousands, is the universe's version of whispering when you expect a shout. When that discovery was first announced, one journalist described it as galaxies marooned in intergalactic darkness. The phrase stuck, equal parts romantic and terrifying. You imagine each of those galaxies like candles in a cathedral so large that even light has stage fright. You pass another one now, smaller, elliptical, its stars old and red. Its gas has long since been used up, no new suns are being born, yet it still glows softly, an ember in the cold. The ancient light leaking from it began its journey before mammals existed on Earth. You can't help but admire its endurance. If there's a cosmic metaphor for persistence, this is it, a galaxy refusing to go quietly, shining for no audience but the void itself. A quirky observation from astronomers studying these systems: many void galaxies seem to be unusually symmetric, perhaps because they've avoided the gravitational tugs that distort others. In the chaos of clusters, galaxies often look mangled, their arms torn by collisions. Here, everything keeps its shape. The void is both womb and tomb, protective but isolating. You find yourself oddly jealous. Imagine living without interference, without cosmic traffic. Of course, you'd also have no one to talk to, but maybe that's the price of peace. You let your gaze drift back toward the faint web of galaxies marking the void's boundary. They look impossibly far away, tiny glimmers outlining the edges of an invisible bubble. From here, the cosmic web seems reversed. The filaments form the walls, and you're floating inside the hollow. Perspective is everything. From this angle, the universe feels as like an enormous lantern, its light coming from the edges rather than the center. Maybe that's the true nature of existence, illumination born from boundary. Historians still argue whether the isolation of void galaxies affects their dark matter, halos. Simulations suggest they may be lighter, less tightly bound, and therefore expand slightly faster than their clustered counterparts. In that sense, even galaxies feel the loneliness of their environment. Emptiness changes how they live, how they age, even how they hold themselves together. You think of people that way too, how solitude reshapes us, sometimes softening the edges, sometimes stretching the light. You realize the lonely galaxies aren't exceptions, they're essential. Without them, the void would be perfectly empty, and the universe would have no reference for its own scale. Their light gives meaning to absence. Their isolation defines connection. In some poetic sense, every human staring at the night sky is doing the same thing, shining briefly into the dark, hoping someone somewhere notices. You take one last look at the void's quiet inhabitants before drifting away, the dim spirals fading into black. Behind you, a single galaxy flickers, then steadies, a stubborn lighthouse on an infinite shore. Ahead, you can already feel the subtle pull of gravity again. The next mystery gathering shape, the invisible hand sculpting even the emptiness. The light from that lonely galaxy fades behind you, and you begin to sense something invisible, something both patient and powerful, the presence of gravity itself. The universe's quiet architect. You've seen what it does to matter, gathering dust into stars, stars into galaxies, galaxies into clusters. But what it does to emptiness is somehow more astonishing. Gravity sculpts voids as delicately as it sculpts worlds, shaping the very absence of matter into form. You drift along one of those invisible curves now, tracing the edges where attraction meets expansion, where the nothingness itself seems to breathe. In the beginning, the universe was nearly uniform, tiny ripples of density. Mere 1 part in 100,000 differences floating in the cosmic soup. Gravity amplified those ripples over billions of years, pulling matter inward into filaments and leaving behind regions of lower density that expanded faster. The result is what you see now, a universe that looks like lace from afar, but up close feels like a slow-motion explosion sculpted by its own imbalance. Historians still argue whether the first gravitational seeds came from quantum fluctuations during inflation or from something stranger, maybe relics of primordial energy that refused to smooth out. Either way, you're floating inside their consequence. A quirky tidbit. In 2014, scientists using the Sloan Digital Sky Survey simulated how voids evolve and discovered that they don't just sit there, they actively push. As the universe expands, voids grow by merging, their low-density interiors inflating faster than the average expansion rate. When two voids collide, the thin wall of galaxies between them dissolves, leaving an even larger bubble behind. It's as if nothingness has elbows, shoving matter aside to make more room for itself. You imagine gravity standing at the center of this cosmic dance, both sculptor and saboteur. At first, that sounds contradictory. How can gravity, which pulls, also make space for emptiness? The trick is perspective. Gravity pulls matter toward matter, which means that regions with less matter get left behind as the denser areas collapse inward. Those under-dense zones naturally expand faster, not because they're being pushed, but because there's less mass slowing them down. It's the universe's version of last one out closes the door. The result is a kind of gravitational differential. Dense regions slow down, voids speed up, and the balance creates the illusion of structure expanding into chaos. You realize you're witnessing a paradox made of math. The more gravity pulls in one place, the more emptiness blooms elsewhere. Historians still argue whether these expanding voids might subtly influence the large-scale flow of galaxies, their collective drift toward or away from certain regions of space. Observations of peculiar velocities show that even vast clusters are not standing still. They're surfing gravitational gradients like buoys on invisible waves. The local group, including the Milky Way, moves toward the Virgo cluster and away from the local void. You picture it vividly, gravity tugging on one side, emptiness stretching on the other, and your galaxy caught between attraction and escape. Maybe balance, not rest, is the true state of the universe. There's a kind of slow music to all this motion. You imagine the voids as deep sonant drums expanding their skins, while clusters hum a low counterpoint of compression. Together, they form a cosmic rhythm that plays out over eons, an orchestra without audience, without conductor, yet somehow perfectly in tune. That rhythm even affects how light travels. Photons entering a void lose a bit of energy as they climb out of surrounding gravitational wells, their wavelength stretching, their colour reddening. The emptiness literally paints the light as it passes. A quirky moment in the scientific history. When Isaac Newton formulated his law of universal gravitation, he imagined gravity acting instantly across space, a mysterious pull between masses. Centuries later, Einstein corrected him, showing that gravity isn't a force at all but the curvature of space-time itself. Yet even Einstein might have been startled to learn that the same curvature shaping stars also shapes voids. Space doesn't just curve around matter, it curves around the absence of matter too. The fabric bends where there's less weight, forming gentle bulges rather than deep wells. You could say the voids are the hills of the cosmic landscape and galaxies are marbles rolling off them. Historians still argue whether those curves could accumulate to mimic dark energy's effect. Some cosmologists propose that as light moves through these expanding regions, the cumulative redshifts might make the universe appear to accelerate. Others say the numbers don't add up, that gravity's trickery, elegant as it is, can't replace the mysterious push of vacuum energy. Either way, the idea that emptiness can shape destiny feels beautifully subversive. You drift along one of these gravitational hills, feeling the pull of denser regions in the distance and the gentle outward stretch within the void. It's like floating on an ocean current that moves so slowly you only realize it's carrying you when the horizon shifts. Galaxies cling to the edges of these flows, tracing out cosmic geography. If you could mark their paths with luminous paint, you'd see great rivers of matter cascading toward clusters, threading through the dark like veins feeding a heart you'll never reach. And then, almost imperceptibly, the thought occurs, this process never stops. Gravity never sleeps. The universe might cool, stars might die, but the curvature persists. Even in the far future, when only faint embers of galaxies remain, space-time will still ripple and stretch, carving new shapes into the dark. Emptiness will continue to expand, not as nothing, but as an echo of everything that once was. You think of your own small gravity, the pull between people, the invisible networks of attraction that bind lives together. The same math that governs galaxies governs those connections. Distance weakens them, mass strengthens them, and time always stretches them thin. Perhaps that's why the study of gravity feels so human. It's the universal law of longing. You look once more into the void, where gravity and expansion are still arguing silently, their dialogue written in the slow drift of galaxies. You can't tell who's winning, and maybe that's the point. The universe, like any great story, needs tension to exist, and gravity, gentle, relentless gravity, is the hand that keeps turning the pages. You drift along the gravitational hills until the invisible landscape tilts again, carrying you toward an idea more unsettling. The possibility that our entire cosmic neighborhood sits inside a vast underdense region, a gigantic void so large that it might bend not just space but truth. The thought surfaces every few decades in cosmology. What if the universe only looks like it's accelerating because we happen to live in a gravitational dip, a bubble that tricks our instruments and our logic? The phrase, the edge of belief, fits too well. Tonight you're standing there, peering out from inside that hypothetical void and trying to decide if the evidence of dark energy is real, or if it's an illusion drawn by perspective. The idea isn't new. In the early 2000s, a group of cosmologists revisited an older model from the mid-20th century, the Lemaitre-Tolman-Bondi solution of Einstein's equations, which allows for a universe that's not uniform. In that scenario, you could sit near the center of a giant underdensity and still observe an isotropic cosmic background. The expansion rate would appear to accelerate because light from distant galaxies would pass through regions with different gravitational potentials. Historians still argue whether that interpretation undermines or complements the cosmological principle, the cherished assumption that the universe looks the same everywhere. To some, suggesting that we live in a special place feels like heresy. To others, it's simply geometry. You imagine the KBC void again, the one named for Keenan, Barger and Cowie, stretching nearly 2 billion light-years across, its density about 20% lower than average. If we really sit inside it, then our local expansion rate could be slightly faster than the cosmic mean, which might explain why measurements from nearby supernovae disagree with those from the cosmic microwave background. It's the infamous Hubble tension wrapped in an existential bow. Either the universe's physics changes over time, or we're measuring from an odd neighborhood. The former breaks our equations, the latter breaks our pride. A quirky tidbit. If you could somehow see the KBC void from outside, if you stood on a cosmic balcony and looked back, it might appear as a faint bubble of dimmer galaxies, a translucent patch in the cosmic web. The edges would shimmer where density increases, marking the boundaries that separate inside from out there. But since light itself bends and reddens as it travels, no one can actually see the void directly. We can only infer it through patterns, motions, and probabilities. It's like trying to prove your art in a fog by measuring how your flashlight dims. Historians still argue whether such a huge structure could have formed naturally in the time since the Big Bang. The standard model of cosmology says the universe should be fairly smooth on scales larger than a few 100 million light-years. A 2 billion light-year wide cavity would be a statistical oddity, a cosmic lottery ticket. And yet, Anomalies keep whispering. Galaxy surveys reveal subtle gradients. Supernova brightnesses fluctuate just enough to keep the theory alive. Even if the KBC void isn't as deep as once thought, smaller voids could collectively mimic its effect, like a choir of tiny distortions singing the same misleading note. You hover near the edge of belief now, halfway between skepticism and wonder. If the void hypothesis were true, it would mean the universe's acceleration might be an illusion, a local trick of geometry rather than a universal force. Dark energy, that mysterious placeholder filling textbooks, could vanish overnight, but that possibility also means humanity occupies a privileged location near the centre of a massive bubble. You can almost hear Copernicus groaning. For 5 centuries, we've insisted we're not special, and now the data taunts us with the possibility that we are. Cosmologically lonely, but special. A fun comparison. In the 16th century, when Galileo pointed his telescope at Jupiter and saw its moons, he shattered the belief that Earth was the cosmic centre. Now, 4 centuries later, we might be circling back, not out of arrogance, but out of statistical weirdness. If our cosmic coordinates do happen to lie near the middle of an underdensity, then our measurements of cosmic expansion will always be biased. Every time a photon crosses that void on its way to us, it experiences less gravitational pull, stretching its wavelength and faking the effect of acceleration. The cosmos becomes a hall of mirrors, and we're stuck inside the most flattering one. You think of light as gossip. It never lies outright, but it repeats what it's heard, distorted by every medium it passes through. The farther it travels, the more rumours it collects. So when our telescopes listen to the universe, they're eavesdropping on billions of years of hearsay. The void might just be a bad connection, a region where the signal drops, making the story sound grander than it is. Historians still argue whether the void model can ever be definitively tested. Some propose mapping supernovae in multiple directions to look for subtle asymmetries in brightness. Others rely on baryon acoustic oscillations, those ancient sound waves fossilized in galaxy distributions, to reveal whether our neighborhood's density really differs from the average. Every new dataset seems to hint at something interesting, only to pull back into statistical ambiguity. The universe is a master of mixed signals, but beyond the equations lies something more emotional. Standing here, metaphorically at the edge of a hypothetical cosmic bubble, you realize how fragile our cosmological faith is. A single assumption, the belief that we're not special, anchors the entire framework of modern physics. Without it, everything from dark energy to cosmic age becomes uncertain. Maybe belief, not observation, is the real scaffolding of the universe. A quirky historical echo. In medieval maps, when explorers reached unknown territory, they scribbled "Here be dragons." Cosmologists do something similar. When faced with anomalies like the cold spot or the Hubble tension, they sketch new parameters, fresh constants, entire dark components. Maybe that's our new dragon, dark energy, or maybe it's just a shadow cast by a void. Either way, it reminds you that the map is never the terrain. You take one last look outward, imagining what lies beyond our suspected bubble. Filaments thicken, galaxies crowd, gravity deepens. The universe there feels heavier, more mature. In here, inside our airy cocoon, space feels lighter, faster, almost impatient. Whether that difference is real or illusion doesn't matter tonight. What matters is the humility it demands. To admit that even after centuries of observation, we might still be measuring from inside a distortion, mistaking our local hollowness for cosmic truth. And as that thought settles, you realize the edge of belief isn't a line at all. It's a horizon. We approach it, peer across, and then the universe quietly redraws it farther away. You hang at that imagined horizon, the edge of belief fading into pixels of data, and for a moment you stop looking outward and glance into something built by human hands, a computer simulation of everything. Astronomers, after all, can't step outside the cosmos to see it whole, so they do the next best thing. They build it. You slip gently into one of those artificial universes now, a digital cosmos humming quietly in a supercomputer's cold heart. This is simulated emptiness, the laboratory of modern cosmology, where equations dream. The room is dark except for the glow of code. Rows of processors whisper, moving trillions of calculations every second, crunching the same laws that govern galaxies. The simulation begins not with light but with randomness, a nearly uniform grid of matter and dark matter trembling with tiny quantum seeds. Then gravity takes over. You watch as points collapse into filaments, filaments into clusters, leaving between them the same haunting voids you've wandered through. Historians still argue whether these simulations prove our theories or merely illustrate them, but there's no denying their beauty. The voids blossom like black flowers across the computational field, each one a precise echo of the ones mapped by telescopes. A quirky tidbit: one of the most famous digital universes, the Illustris simulation, contains more than 12 billion particles of dark matter and gas, each representing entire galaxies' worth of mass. It runs over tens of millions of virtual years, compressing cosmic history into a kind of time-lapse ballet. In 2014, when scientists released a video of the results, it went viral. People stared at their screen, hypnotized by the unfolding filaments, unaware that they were watching numbers pretend to be reality. You drift into that simulation now, floating between artificial galaxies that glow with algorithmic starlight. Even though it's all math, you feel a strange tenderness for it. The computer has dreamed something familiar: order out of void. The researchers who run these models are cosmic gardeners. They tweak parameters: dark energy density, matter composition, initial fluctuation amplitude, like adjusting soil and sunlight. Then they let gravity and expansion do the rest. Within minutes, the simulation produces a cosmic web statistically indistinguishable from the real one. Historians still argue whether this means we truly understand the universe or merely mimic it convincingly. After all, predicting structure doesn't mean knowing why it exists. Even a shadow can look perfect if the light's right. You glide between virtual filaments, noticing how the digital voids stretch and merge in much the same way their real counterparts do. It's uncanny. In one corner of the simulation, a supervoid forms early, draining surrounding material like a whirlpool of nothing. Later, it grows so vast that it alters the simulated Hubble flow, changing how galaxies drift. Watching it, you understand why cosmologists trust these models. They're the only way to see the invisible, to watch emptiness move into real time. You feel almost guilty for calling it nothing. A quirky historical note: the first cosmological simulation was run in the early 70s, when computers filled entire rooms and their storage was measured in kilobytes. That crude model used only a few hundred particles and still revealed the earliest hints of filamentary structure. Imagine the excitement, scientists realizing their clunky machine had just recreated the skeleton of the cosmos. Historians still argue whether those primitive simulations were too simplified to matter, but every great discovery begins as an approximation that dares to believe it's enough. As you float deeper into this artificial cosmos, you notice something uncanny. The voids here have personality. Some expand quickly, others lag behind, some trap small galaxies along their rims, others swallow them whole. The behavior emerges naturally from gravity's equations. No need to program emptiness. The laws alone are sufficient. It's almost philosophical. Once you define attraction and expansion, the voids take care of themselves. Nothingness organizes automatically. You start to wonder if the real universe is doing the same, if the grand pattern you see is simply the inevitable consequence of math existing. Historians still argue whether our universe might itself be a kind of simulation, a question that's drifted from science fiction into respectable debate. You smile at the symmetry. We build digital universes to understand our own, and now we suspect we might be living inside one. Maybe the cosmic voids are the program's negative spaces, the parts where no computation needs to happen. The thought makes your skin prickle. Though in zero gravity, there's no reason for goosebumps. You pass near a simulated galaxy cluster glowing blue in false colour. It's beautiful but eerily static. The simulation freezes at a single epoch so scientists can study the structures. You can zoom in forever and never find life. Only data, numbers representing the average properties of stars, not their stories. Yet somehow that lifeless perfection feels more serene than bleak. Maybe this is how the universe sees itself, a pattern without preference, a calm equation humming endlessly. A fun fact buried in the simulation code: even dark matter, the mysterious glue that holds galaxies together, behaves predictably enough to model. By adjusting its density and interaction strength, scientists can reproduce the large-scale structures we actually observe. The dark, it seems, obeys. Only dark energy, the driver of expansion, remains inscrutable, a parameter rather than a process. To run a simulation, researchers simply assign it a value, a number dictating how fast emptiness should grow. That line of code might be the most poetic thing humans have ever written. Accelerate the void by 0.7 of the critical density. You hover there, marveling at the irony. In trying to model everything, we have to hardcode mystery. The universe may be vast and elegant, but it's also lazy. It only needs a few simple rules to make complexity appear inevitable. The same principle applies here in your mind. A few rules of wonder, and the rest is self-organizing curiosity. Historians still argue whether simulations will ever reveal something fundamentally new, or whether they'll only confirm what we already assume. Yet when you look around this artificial cosmos, its luminous filaments and patient voids, you feel a kind of affection for the attempt. Even if the model isn't perfect, it's a confession of awe rendered in math. Humanity, trapped in one small galaxy, dares to imitate creation just to see if it can. You let yourself dissolve into the digital dark, watching galaxies fade into lines of code, and whisper a quiet thank you to the scientists, to the machines, to the universe for being so copyable. In this simulated emptiness, you understand that imitation is also worship. The void, whether real or rendered, still teaches the same lesson. That meaning comes not from what fills space, but from the patience to measure what doesn't. And as the virtual stars flicker out and the processors hum into silence, you feel the next question stirring, the one that asks whether the void itself might one day speak back. When the simulated stars wink out, you expect silence, but instead you hear a faint hiss, the soft, constant background hum of the real universe bleeding through imagination. You're listening to nothing, and yet it sounds alive. Tonight you'll learn what it means to listen to the void, because scientists have built instruments that try to do exactly that. They point radio dishes, microwave antennas, and laser interferometers toward the dark, hoping that emptiness itself might whisper back. Welcome to the strange art of eavesdropping on nothingness. The first voice of the void arrived by accident. In 1964, two engineers, Arno Penzias and Robert Wilson, were testing a new Bell Labs microwave antenna when they detected a persistent noise that refused to go away. They thought it might be pigeon droppings in the equipment. It wasn't. It was the faint afterglow of the Big Bang, the cosmic microwave background. That hiss was 13.8 billion years old, stretched by the expansion of space until it became the soft static of creation. Historians still argue whether the duo immediately grasped the significance of their discovery, or just wanted the noise to stay. Either way, they had accidentally tuned into the oldest broadcast in existence. You listen again now, floating through that same radiation field. It's everywhere. Inside your room, your phone, the gap between your thoughts. The signal is almost uniform, but not perfectly. Small temperature variations, microkelvins of difference, map the seeds of galaxies. When scientists first converted that data into color maps, they were astonished. The voids and filaments you've seen all night began as those tiny fluctuations in the static. The universe spoke in whispers long before it shouted in stars. A quirky tidbit: that microwave background is so pervasive that about 1% of the snow on an old television screen comes from it. Every time someone in the 20th century stayed up too late staring at TV static, they were unknowingly watching the birth cry of the cosmos. You can't decide whether that's comforting or creepy, maybe both. But listening to the universe doesn't stop with microwaves. Scientists have started tuning to even deeper channels, frequencies where sound doesn't exist, but vibration does. Gravitational wave detectors like LIGO and Virgo stretch lasers across kilometers of vacuum, waiting for ripples in space-time to make those beams tremble. When two black holes collide billions of light years away, the distortion passes through Earth, stretching and squeezing it by less than the width of a proton. That's what counts as loud on the cosmic scale. You imagine the void ringing like a drum struck by invisible hammers. Historians still argue whether these gravitational ripples should be considered sound. After all, they travel through the geometry of space-time, not air. Yet scientists often sonify the data, translating the signals into audible chirps. When the first detection was announced in 2015, the noise was barely a second long, a quick whoop sliding upward in pitch. To the untrained ear, it sounded trivial. To physicists, it was the universe confirming Einstein's century-old prediction. The void had hummed, and humanity had finally heard it. You imagine drifting near one of those instruments, its vacuum tubes gleaming under starlight, lasers humming in perfect phase. Inside, mirrors hang suspended by glass fibers, so delicately balanced that the passing of a cosmic ripple can make them shift by a fraction of an atom. The machinery feels devotional, almost monastic. Each component listens with inhuman patience, waiting years for a whisper that might never come again. To measure nothing, you need faith. A quirky footnote from the archives. When LIGO was first proposed, many physicists dismissed it as impossible. You're trying to measure silence with rulers that vibrate more than the signal, one skeptic said. Yet after decades of engineering and billions of dollars, it worked. The void, once thought perfectly still, turned out to be rhythmically alive. Even absence keeps time. The listening grows stranger the deeper you go. Radio astronomers now use vast arrays, fields of metal dishes, or even entire deserts wired with antennae to detect the faint neutral hydrogen emissions that trace the cosmic web. They're mapping the whispers of gas between galaxies, the thin plasma that outlines the boundaries of voids. The square-kilometre array, still under construction, will be the largest ear the planet has ever built, capable of hearing hydrogen murmurs from when the first stars lit up. The instruments don't seek loud signals, they chase the hush between them. You find that poetic. We're building bigger and bigger machines just to measure quieter and quieter things. Historians still argue whether these subtle emissions will one day reveal something unexpected, perhaps variations in the cosmic expansion rate or new physics lurking in the silence. Others believe the void will keep its secrets, giving us only what the math already predicted. You side with the dreamers again. If the universe can surprise us once, it can do it twice. You lean into the hum. It's there if you know how to listen, a sound without sound, a constant vibration woven into every atom. Even your body resonates with it. Every electron in you once shared the same primordial orchestra pit as the photons filling space. To exist is to echo. Then the listening turns inward. You notice how silence isn't truly silent. In a quiet room, your ears invent phantom noise, a faint rush of blood, the ring of nerves. Maybe the universe does that too, fabricating tiny fluctuations in its vacuum just to avoid total stillness. Quantum physics agrees. Even at absolute zero, the void seethes with virtual particles popping in and out of existence, ephemeral sparks that vanish before they can be seen. The hum of the void is the sound of possibility never quite realized. You smile at the irony. We spent millennia trying to silence the world enough to hear the heavens, and now that we finally can, the heavens whisper back with static. Still, you keep listening, because within that static lies everything, the echo of the Big Bang, the footsteps of black holes, the breath of space-time. The void isn't mute, it's just speaking a language so slow that only patience can translate it. As the faint cosmic hiss surrounds you, you feel an unexpected warmth. The silence between galaxies is vast but not empty. It's filled with all the notes of creation stretched thin, a lullaby played on the strings of time itself. You close your eyes and let the void sing you to sleep. The hum fades into motion. You begin to sense not just the vibrations of the void, but the flow, the slow migration of whole clusters through space, sliding like icebergs across an invisible sea. Astronomers call this the cosmic flow, and among its strangest currents is something they've named the phantom flow, the peculiar drift of galaxies toward regions that appear to contain no source of gravity strong enough to cause it. You can picture it like this: tens of thousands of galaxies, each a glittering metropolis, all streaming in the same direction as if pulled by an invisible tide beyond the edge of observation. You hang there, weightless, watching entire worlds glide towards something that technically isn't there. The story began in the late 1970s, when astronomers noticed that our own local group wasn't moving randomly. The microwave background showed a dipole pattern, hotter in one direction, cooler in the opposite, indicating that our galaxy was speeding at about 600 kilometers per second relative to the early universe. Where were we going? Toward the constellation Centaurus, roughly. The culprit was eventually named the Great Attractor, a dense concentration of mass some 100 million light-years away. But as mapping improved, it became clear that even the Great Attractor was moving, drawn by something farther still. The Shapley concentration, a monstrous supercluster. Historians still argue whether this chain of pulls fully explains the motion we see, or whether there's another hand, an unseen gravity, a phantom tugging from beyond the horizon. A quirky tidbit: one of the earliest press releases about the Great Attractor described it, half seriously, as the largest known case of cosmic peer pressure. Galaxies that had minded their own business for billions of years suddenly appeared to be following their neighbours into the same direction of space. You imagine them gossiping in gravitational tones. Everyone's heading that way. Don't get left behind. The phrase stuck because it felt oddly human. Even galaxies, it seems, are susceptible to trends. As you follow the phantom flow through imagination, you pass clusters tumbling together like schools of fish, their dark matter halos overlapping. The velocities are small compared with the speed of light, yet the collective motion spans hundreds of millions of years. From this perspective, you can almost see gravity as wind, steady, relentless, impossible to feel until you measure it against the background. The voids themselves expand while the dense regions drift, giving the impression that the universe is both inhaling and exhaling at once. Historians still argue whether the so-called dark flow detected in 2008 was a real phenomenon or a statistical mirage. Using NASA's WMAP data, a team led by Alexander Kashlinsky claimed to find evidence that galaxy clusters were streaming toward a single point far beyond the observable universe, moving faster than standard cosmology allowed. The news made headlines. Maybe something outside our cosmic horizon, perhaps another region of the multiverse, was pulling at us. Later analyses with Planck data cast doubt on the result, but the phrase dark flow refuses to die. There's poetry in it. A river of galaxies gliding toward the unknown. You drift alongside that imagined current, letting its scale wash over you. Each bright smear of light beneath you is a cluster containing thousands of galaxies, each galaxy containing hundreds of billions of stars, all of it moving together slowly, silently. The distances are so large that even at 600 kilometers per second, a galaxy would need 10 trillion years to cross the sky. Motion here is a kind of eternity-wearing shoes, a fun historical comparison. Centuries ago, sailors noticed ocean currents long before they could explain them. They dropped bottles into the water and waited years for the glass to wash ashore elsewhere. Cosmologists are doing the same thing, only their bottles are photons. Every ray of light we collect is a message from a drifting galaxy, hinting at the invisible tides beneath space-time. You can almost imagine future historians calling us the bottle throwers of the void. As you move deeper along the flow, the gravitational map grows complex. There are pockets where matter stalls, eddies where the currents circle back, regions where voids act like low-pressure zones guiding traffic. The boundaries between attraction and repulsion blur. It dawns on you that the universe is less like a static structure and more like a fluid, viscous, turbulent, restless. Galaxies aren't fixed dots. There are plankton drifting in spacetime's ocean. Historians still argue whether these motions mean anything beyond local variations. Perhaps every patch of the universe has its own peculiar flow, and ours just happens to point towards Centaurus. Or perhaps the flow reveals something profound, a hint that spacetime itself has a texture, ripples left by forces beyond our models. Either way, the lesson repeats. The universe resists stillness. Even nothing moves. A quirky side effect of these flows is how they distort our cosmic maps. Because galaxies are in motion, their redshifts don't perfectly correspond to distance. Some are moving toward us within an overall expansion. Astronomers must correct for these peculiar velocities to build accurate 3D charts. You think of it as cosmic GPS lag, our coordinates constantly updating as the universe rearranges itself. Somewhere out there, a data scientist is literally tracking the drift of the void. You imagine standing at the prow of this invisible current, your body weightless, your hair tugged by gravitational wind you can't feel. Ahead lies the unseen attractor, behind the widening emptiness. You understand then that motion and stillness are illusions of perspective. From inside the flow you move, from the universe's frame you simply are. Both truths coexist, just as galaxies both fall inward and expand outward. A quiet thought surfaces. Maybe purpose itself works like gravity. We feel pulled towards something we can't see, invent names for the attraction, argue about its cause, and keep moving anyway. The cosmos teaches patience through momentum. Even without knowing what draws you, you drift forward. You look once more at the phantom current sweeping across creation and realize it doesn't matter whether the pull comes from a supercluster, a void, or some physics still unnamed. The beauty lies in the motion, the shared journey of billions of galaxies responding to the same invisible invitation. The universe, it turns out, is not static artwork but choreography, and you, small as you are part of the dance. The dance carries you onward, the cosmic tide tugging you between filaments and voids until the sensation shifts again. Motion slowing, expansion stretching, everything thinning toward transparency. You're now inside the paradox itself, the great irony that defines modern cosmology, when nothing expands. The more the universe grows, the less of it there seems to be. Yet expansion isn't about matter flying apart into pre-existing space. It's about space itself's growing, fabric pulling its own threads outward. You float there, feeling no wind, no push, just the steady lengthening of distance. It's so smooth you'd miss it if not for the redshifted glow of galaxies retreating, light elongating like syrup poured across time. The first person to suspect this was a Belgian priest with a gift for mathematics, Georges Lemaitre. In 1927, he proposed that the universe was expanding from a primeval atom, an idea that later became the Big Bang. 2 years later, Edwin Hubble confirmed the expansion through galactic redshifts. Historians still argue whether Hubble truly understood the cosmological meaning or simply plotted a correlation. But together they cracked open eternity. It turned out that space wasn't a static backdrop, it was a restless participant, an elastic canvas constantly unrolling beneath our feet. A quirky tidbit: if you freeze the universe in your imagination and paint a 1-meter grid across it, in a billion years every square would be slightly larger, but you'd never see the fabric stretch locally. Atoms don't inflate, solar systems don't balloon. Gravity and electromagnetism hold small things together while the larger scale expands. It's like watching raisin bread rise in the oven. The raisins stay the same size, but the dough between them swells. You smile at the absurd coziness of that metaphor. Our galaxy is a warm, slightly toasted raisin drifting through cosmic dough, but the real mystery comes from what drives the rising. Since the late 1990s, observations of distant supernovae have shown that the expansion isn't slowing as gravity should make it, but accelerating. Something we call dark energy is pushing space to stretch faster and faster. Historians still argue whether it's a true energy of the vacuum, a new field, or a misunderstanding of gravity itself. Whatever it is, it makes up about 70% of the universe. That means most of reality is an invisible pressure inflating nothing. You've spent your whole life inside an expanding emptiness that outvotes matter 7-3. You think of vacuum energy as the universe's default mood. Even when you remove all particles, all heat, all light, you're left with fluctuations, tiny bursts of existence appearing and vanishing. Quantum physics forbids true stillness. The uncertainty principle guarantees that emptiness fidgets. Those jitters give vacuum energy its subtle pressure. As space grows, the energy doesn't dilute, it multiplies. The more nothing there is, the more power it carries. It's the only investment that gains interest by having less. A fun historical note: Einstein once introduced a cosmological constant to keep the universe static, then later called it his biggest mistake. Decades after his death, that same constant reappeared as the simplest form of dark energy. Historians still argue whether Einstein would have laughed or groaned. Probably both. You picture him scribbling equations, muttering, "I told them space could be dramatic." The expansion has tangible consequences. In a few billion years, distant galaxies will slip beyond our cosmic horizon. Their light stretched until it fades entirely. Future astronomers in some far epoch will look up and see only the local group, unaware that a larger universe ever existed. The void will win by default, not through destruction, but through dilution. Existence will fade into privacy. You imagine that quiet future, a dark sky, one remaining spiral galaxy glowing faintly, time itself expanding faster than memory. There's a deeper melancholy beneath the physics. When you realize that nothing has agency, that emptiness can accelerate and create, it challenges every intuition you have about cause and effect. Philosophers once asked why there is something rather than nothing. Now cosmologists ask how nothing can behave like something. Maybe the two are the same word spoken in different tempos. Historians still argue whether darker energy is constant or variable. Some data hint it might evolve like a field's slowly changing strength as the universe ages. Others insist it's a fixed property of space-time, eternal and unchanging. Either option feels eerie. If it's constant, then expansion will continue forever. Galaxies drifting apart until even atoms can't find each other. A heat death of infinite loneliness. If it varies, it could one day reverse, collapsing everything back into a big crunch. The cosmos, it seems, can't decide between endless solitude and sudden reunion. You picture the expansion not as an explosion but as breathing, slow, cosmic inhalation. Every second, more space exists than before. Somewhere beyond visibility, new voids are born, each carrying the same laws, the same restless tendency to grow. You begin to understand why cosmologists sometimes sound poetic. The equations are too grand to read aloud without reverence. A quirky experiment once proposed by physicist Alan Guth imagined what would happen if you could isolate a small patch of false vacuum, a region with slightly higher energy density. Quantum theory predicts it would inflate exponentially, birthing a new universe. In other words, our own cosmos could be the byproduct of a tiny bubble of vacuum gone unstable. If that's true, expansion isn't just happening, it's contagious, nothingness reproduces. You shiver at the thought. Every cosmic void might secretly be pregnant with new creation. As you drift in that understanding, the edges of perception stretch too. The galaxies recede until they become faint stains of colour, then disappear altogether. Only the smooth gradient of space remains, featureless, luminous, expanding. You realise that to witness expansion from within is to feel no motion at all, only distance accumulating silently. The universe grows not like a balloon, but like a thought, unfolding in every direction at once. Maybe that's the secret of peace, to let everything expand without resistance. The cosmos doesn't ask permission, it just becomes more of itself. You breathe with it, matching your inhale to the quiet swelling of space, your exhale to the fading of starlight. For a moment, you and the void are the same process, two versions of nothing learning how to grow. And somewhere, in that infinite stillness, a faint tug reminds you that even as space expands, one small planet remains bound to its own rhythm. You turn your gaze back toward home, ready to notice how human emptiness mirrors the cosmic kind. You turn inward, finally, back toward the little blue marble that started this whole thought experiment, and you can't help laughing softly at the symmetry. After drifting through voids billions of light years wide, you realize Earth has built its own miniature versions. Tiny social and digital bubbles expanding just as stubbornly as the cosmic kind. Welcome home to the human bubble, a universe of group chats, timelines, curated feeds, and apartment walls, all orbiting personalized vacuums. It's not that we invented isolation, it's that we industrialized it. Look around on an average morning. Someone scrolls through news tailored by algorithms, another talks only to like-minded colleagues through encrypted channels, while next door a gamer logs into a virtual city populated entirely by avatars who agree with him. Each pocket feels full, yet each one filters out more of the outside. Historians still argue whether the internet liberated information or simply rearranged ignorance into prettier clusters. Either way, it's astonishing how well the humanist psychology mimics cosmology. When connection becomes too dense, tension builds, then expansion, digital, emotional, social, pulls everything apart until new voids appear. A quirky tidbit. The first recorded use of the term echo chamber predates social media by over a century. In the 1830s, it described certain theatre designs where a whisper bounced endlessly between curved walls. The architects considered it a flaw. Now we call it engagement. Our technologies recreate the same acoustics, words circling, amplified, distorted, until meaning becomes background hum. You wonder if Penzias and Wilson's cosmic hiss might have been the universe's own echo chamber, a reminder that even creation had feedback issues. You picture humanity from a cosmic distance, not as individuals, but as a shimmering network of lights blinking across continents. At first it looks random, but patterns emerge. Clusters of urban glow separated by stretches of dark wilderness, each metropolis connected by filaments of highways and data cables. It's the same geometry you saw out there between galaxies, the cosmic web reimagined in LED. The resemblance isn't coincidence. It's the mathematics of connection repeating itself at a smaller scale. Gravity gathers matter, curiosity gathers minds, and both leave hollows where nothing flows. Historians still argue whether our modern isolation is an evolutionary glitch or a necessary phase. Some sociologists think humans expand networks the way the universe expands space, relentlessly until communication itself thins. Too much density leads to collision, misunderstanding, burnout. Too much emptiness breeds apathy. Somewhere between the two lies equilibrium, the human equivalent of dark energy balancing gravity. Maybe empathy is our cosmological constant. You drift through a digital void now, scrolling through imaginary feeds that stretch to infinity. Every post is a galaxy, every reaction a flicker of radiation. You sense the same paradox that defines the physical universe: infinite connection leading to infinite distance. The more voices you can hear, the less any single one stands out. It's as if the expansion of data dilutes meaning, the way the expansion of space dilutes light. You smile at the absurdity. A meme behaves like a photon, redshifting into irrelevance as it travels. A quirky sociological note. Studies show that the average person today communicates with more people in a week than a medieval villager met in a lifetime. Yet loneliness statistics have never been higher. The signal-to-noise ratio of existence keeps dropping. We're surrounded by the messages, but starved for conversation. Maybe that's why you feel drawn to cosmic metaphors. At least the universe doesn't pretend its void is full. You think back to those isolated galaxies in the Boötes void, self-contained, slow-evolving, serene. Perhaps we envy them. The modern world hums like a dense cluster, everyone orbiting everyone else. Gravitational pull from opinions and trends compressing the space where independent thought might form. So we create smaller bubbles to breathe, little personal voids of quiet, yoga mats, playlists, the sanctuary of airplane mode. Inside those hollows we can expand again. Humanity repeats the cosmos because it must. Creation and retreat, noise and silence, constant oscillation between intimacy and emptiness. Historians still argue whether this cycle will stabilize or spiral. Some futurists predict global empathy networks that collapse all boundaries. Others warn of infinite fragmentation, a future of micro-universes where each person rules a self-contained narrative. The truth, as usual, lies in motion. The social web, like the cosmic one, never stops reshaping. Filaments form when ideas connect. Voids open when trust erodes. Both are necessary for balance. You recall a funny historical parallel. When telegraphs first spread across continents in the 19th century, critics feared information overdose. Newspapers printed letters from readers complaining that constant messages left them anxious and distracted. Replace telegraph with smartphone and the complaint is identical. Time doesn't invent new neuroses, it just updates their firmware. From above, Earth's night side glows like a living map of neural activity. Cities pulse, data streams glimmer across oceans, satellites blink in synchronous orbit. You realize that the planet itself resembles a single mind dreaming. The dark patches between the lights, oceans, forests, deserts, are its voids, necessary gaps allowing the rhythm of thought. Without silence, there's no signal. Without distance, no definition. The cosmos taught that first. Humanity is just catching up. You pause and inhale the real air around you, heavier than interstellar vacuum but equally full of ghosts. Every breath is borrowed carbon exhaled by others, proof that connection still beats isolation. Maybe the real frontier isn't out there among galaxies, but in here, learning how to live with our expanding social universe without losing orbit around kindness. A soft idea takes shape. If the universe expands forever, perhaps empathy must as well. The challenge is to stretch without breaking, to keep the filaments between us luminous even as distance grows. That's the human version of cosmology, a physics of understanding. You glance one last time at the glowing planet, each window and phone screen a tiny galaxy in miniature, each person at a star sending light across the personal voids. You whisper into that endless network, knowing the message will redshift into static, but sending it anyway. You're not alone in your bubble. Then you feel another pull, subtler, higher. Beyond the human lattice lies the outer limit of perception itself, where even observation begins to fray. You follow that pull upward, toward the cosmic horizon, where seeing becomes believing, and believing becomes guesswork. You rise above the human web of lights until even the continents blur, their glitter dissolving into one slow swirl of cloud and shadow. The planet shrinks beneath you, The moon slides by like a coin, and beyond it the solar system flattens into geometry, circles and ellipses drawn on a blackboard of stars. Farther still, the Milky Way fades into a silver ribbon, and you're back where the true horizon begins, the limit of what can ever be seen. This is the edge of observation, the faint line between the knowable and the forever hidden. You hang there, weightless, staring across the boundary where data gives up and imagination takes over. To understand that edge, you first have to remember that the universe has a speed limit, light. No matter how fast we move, we can never catch up to signals travelling faster than light, because they don't exist. The result is a sphere centred on you, the observable universe, about 93 billion light-years across. Anything beyond it is invisible, not because it isn't real, but because light hasn't had time to reach us since the Big Bang. The horizon expands as the universe ages, yet the expansion of space also pulls distant galaxies away faster than their light can approach. Some regions will remain eternally unseen, receding faster than any telescope could compensate. You can sense them out there, ghost realms of matter, infinite but inaccessible. Historians still argue whether this horizon defines the universe's true size, or merely our local patch. Some believe it's finite but unbounded, curved back on itself like the surface of a sphere. Others insist infinity is the simpler answer. A few daring voices propose multiple horizons, bubbles of space-time budding off like cosmic dew. You like that image? Universes as morning condensation on eternity's windowpane, each one glistening for a while before evaporating into new equations. A quirky tidbit: when Edwin Hubble first realized the sky's galaxies were receding, some journalists misreported it as space blowing away from Earth. The public panicked briefly, wondering if we were at the center of an explosion. In a sense, we are, but so is every observer everywhere. Expansion looks the same from any vantage point. That democratic geometry means every being in every galaxy sees themselves as central. The universe, you think, is polite like that. It hands out self-importance equally. You hover closer to the conceptual barrier, where visible galaxies thin into infrared smudges detected only by the most sensitive instruments. Beyond them lies the cosmic microwave background, that pale fossil light from 13.8 billion years ago. It's the oldest thing we can see, the limit of transparency itself. Before that epoch, the universe was opaque plasma. When we look at the CMB, we're not seeing across space but backward in time, into a moment when atoms first formed and the cosmos exhaled light for the first time. Everything beyond that is inference, a darkness we fill with theory. You reach out toward it, knowing that your hand would pass not into another region but into the past. Historians still argue whether the edge is even real. In general relativity, there are no physical boundaries, only limits of information. The cosmic horizon isn't a wall but a distance beyond which events can't influence us. Yet in practice it feels like a veil. Astronomers stare at their data, finding faint distortions in the microwave background that might hint at structures beyond, gravitational fingerprints pressed against the curtain. One rumour in the scientific community says that slight temperature anomalies could be the scars of another universe colliding with ours during inflation. Nothing confirmed, of course, but the possibility lingers like a lone note in the orchestra of speculation. You find the idea thrilling, that somewhere beyond the observable boundary, other universes expand, each with its own physical constants, its own histories, maybe even its own concept of time. Our horizon would then be just one bubble in a froth of infinities. Theorists call it the multiverse, though even they admit it's part philosophy, part math, part existential coping mechanism. Still, it fits the pattern you've seen all night. Voids within voids, bubbles within bubbles. Creation apparently enjoys recursion. A quirky experiment, you recall, involved pointing the Hubble Space Telescope at what looked like an empty patch of sky, no larger than a grain of sand held at arm's length. After weeks of exposure, the image filled with thousands of galaxies. The void was never empty, it was just faint. That discovery, the Hubble Deep Field, remains one of humanity's purest lessons in humility. Even the smallest piece of darkness hides more light than we imagined. You think of it now as you face the ultimate darkness and wonder what would happen if we could integrate for longer, if patience itself could become a telescope. As you float nearer to the edge, The background radiation fades into silence, replaced by something subtler, the awareness that observation itself changes reality. In quantum physics, to measure is to influence. Every act of detection collapses possibilities into facts. The universe you see is partly the universe you've chosen to notice. You realize that the horizon isn't just physical, it's psychological. Beyond the limit of observation lies not emptiness, but potential waiting for attention. Historians still argue whether consciousness has any role in this cosmic equation. Most physicists say no, the universe doesn't care if it's observed, yet the poetic impulse remains. Maybe awareness is how the universe experiences itself. Maybe each gaze adds a small piece of existence to the map. You smile at that notion. After all, the cosmos is 13.8 billion years old and still learning to see itself clearly. You peer one last time across the fading field of galaxies, and the thought occurs that you're looking at a mirror. The farther out you see, the further back in time, until the first light touches your eyes. Light that left its source before eyes existed to receive it. Observation completes the circle. The universe looks at itself through you. The edge of observation isn't the end of seeing, it's the moment sight becomes participation. You let the horizon blur into brightness until the distinction between observer and observed disappears. There's no boundary, no inside or outside, only awareness expanding like space, infinite and unfinished. The edge of observation is, you realize, not a limit, but an invitation. And beyond that invitation, something stirs. The dream of the void itself, waiting to be imagined. You drift beyond the edge of measurable light into a sense that feels thicker than space, a sense that might be thinking. This is the dream of the void. The realm where physics begins to sound like poetry because language runs out of instruments. You're not outside the universe, you're inside its imagination, the place where equations blur into myths again. Everything you've learned about expansion, gravity and structure fades into something softer. The emptiness begins to tell its own story. At first, it speaks through philosophy. You hear echoes of the ancient Greeks, who called the void keinon, a necessary absence that allowed atoms to move. Without emptiness, they said, no motion could exist. The Buddhist teachers had their own version centuries later, shunyata, the voidness of all things, not a negation but a space of infinite potential. Historians still argue whether these early ideas anticipated quantum physics or merely shared its vocabulary of wonder. Either way, the philosophical and the physical converge here in the same quiet realization that nothingness is not the opposite of being, but its foundation. A quirky tidbit: when astronauts on long missions describe the view of deep space, many report an overwhelming calm rather than fear. The emptiness feels intimate, they say, as if the universe is listening. Psychologists call it the overview effect, a shift in awareness caused by seeing the Earth suspended in blackness. You suspect it's something deeper, a brush with the dream of the void, where meaning and scale dissolve together until only gratitude remains. Art has always tried to paint this feeling. You think of Kazimir Malevich's Black Square, that infamous canvas of pure darkness unveiled in 1915. Critics mocked it as nihilism, but the artist called it the face of the infinite. Historians still argue whether he meant spiritual transcendence or aesthetic rebellion. But the message was clear. Even a blank field can contain eternity. Every gallery that hangs it becomes, briefly, a window into the cosmic night. You imagine the void smiling at that, a human attempt to capture its portrait using pigment and faith. Music too has tried. John Cage's 4:30, 4 minutes and 33 seconds of silence, turns the absence of sound into performance. When the pianist sits motionless and the audience listens to coughs, shuffling feet or their own breathing, the piece reveals that silence was never empty at all. It's the same lesson the void keeps teaching. Pay attention long enough and nothing becomes everything. You realize now that the universe may be performing its own version of Cage's piece, a symphony scored in expansion and pause. Historians still argue whether humanity's obsession with emptiness is morbid fascination or creative instinct. In every culture, the void appears as both fear and muse. To some, it's death. To others, rebirth. The Stoics saw it as the rational background of order, while Romantic poets saw it as the sublime. The astrophysicists see it as negative energy density, measurable to several decimal places, which is describing the same thing with different metaphors. a truth too vast to fit inside a single discipline. You wander through that mental museum, moving from philosophy to art to science, until the boundaries dissolve completely. The void becomes a gallery of mirrors reflecting your own questions. Why do humans fear emptiness when they're made of it? 99% of every atom is empty space, yet we call ourselves solid. The same physics that sculpts galaxies shapes the gaps between your cells. You are literally a microcosmic void dreaming of a macrocosmic one. Maybe that's why gazing into deep space feels like nostalgia. The emptiness out there recognizes its kin in here. A quirky psychological observation. Studies on sensory deprivation show that when humans experience perfect silence and darkness for too long, the brain begins to hallucinate light and sound. The mind fills the void automatically, refusing to accept nothingness. Perhaps the cosmos does the same. Maybe the flicker of galaxies is the universe's hallucination against its own solitude, a way for the void to entertain itself. You smile at the thought, creation as cosmic boredom relief. You remember how ancient cultures imagined the world emerging from chaos. Babylonian gods shaping order from watery void. Genesis beginning with darkness upon the deep. Hindu cosmology picturing Vishnu floating in infinite night before dreaming reality into being. Historians still argue whether such myths arose from stargazing or from introspection. Either way, they suggest the same intuition, that emptiness precedes creation, the way sleep precedes dreams. The universe is not a machine, but a sleeper who occasionally wakes to admire its own stars. You let yourself sink deeper into that dream. The physics of it softens until metaphors feel more accurate than numbers. You sense that vacuum energy, the dark expansion you once measured with equations, now hums like a lullaby. Each virtual particle flicker becomes a heartbeat. The void isn't silent, it's breathing. The spaces between galaxies pulse in rhythms too slow for human time. To the cosmos, a billion years is a sigh. Historians still argue whether the universe has consciousness. The safe answer is no, but the poetic one is maybe not yet. After all, consciousness in humans arose from complexity, networks connecting and reflecting. On the largest scales, the cosmic web does the same, filaments transmitting gravity and light like neural impulses. What if the void's dream is simply the slow evolution of awareness? A mind the size of everything still forming its first thought. You can't prove it, but the idea feels kind. It means you're not alone in the dark, you're part of the dark learning to see itself. A final image floats through you. The universe, endless and sleeping, dreaming a single phrase over and over. I exist so that absence can know itself. You hold on to that as the light of galaxies flickers faintly in the distance. The dream of the void, it turns out, isn't about oblivion, it's about reflection. Every empty space is a mirror waiting for light. Every moment of silence is an ear waiting for a song. And now, gently, the dream begins to fade, giving way to the softest pull of all. The slow return home through the dark, back to where you began, back to the small, bright world that dreamed of the universe in the first place. You drift home through the dark, the stars dimming behind you until only the faint blue shimmer of Earth remains, turning slowly in the cosmic night. After travelling through voids and filaments, through theories and dreams, you find yourself hovering above this small planet, the single flicker of warmth in a universe of cold light. You realise you've come full circle, not escape the void but learn to live within it. The emptiness hasn't vanished. It's simply quieter now, less threatening. It's the dark between notes that makes the melody, the space between breaths that lets you live. You inhale slowly, as if syncing your lungs with the expansion of the cosmos. Below, the thin film of atmosphere glows like a halo, soft blues and pinks fading into shadow. From this distance, the continents are merely brushstrokes, clouds swirling like thought. You remember how earlier you learned that the local bubble surrounds us, that ancient supernovae cleared the dust so our night sky could sparkle. That same bubble now seems to cradle the world, a fragile womb of nothing protecting everything. You smile because after 20 sections of cosmic wandering, it's comforting to end where you started, in a pocket of emptiness that feels like home. Historians still argue whether meaning is something we invent or discover. Looking down at Earth, you suspect both are true. The universe doesn't hand out purpose, it hands out conditions. We take the silence and turn it into language, the void and turn it into story. Maybe that's the point of consciousness, not to escape nothingness, but to interpret it. A quirky tidbit. The Apollo astronauts who travelled to the moon often spoke afterward of a strange empathy that lingered for years. They'd look at that blue sphere hanging in the blackness and feel, as one put it, an urge to protect the bubble of life. It's called the overview effect. And you feel a version of it now. From out here, borders, politics and noise disappear. What remains is one shared home, small enough to cup in a cosmic hand. You let yourself descend in imagination, passing through layers of atmosphere dense with whispering winds. The constellations fade above, the air thickens, and soon you're among clouds lit by moonlight, silver rivers in slow motion. Beneath them, the cities glow, constellations turned upside down. Streetlights trace filaments, highways shimmer like veins, and between them lie dark patches, forests, oceans, deserts, the Earth's own voids. You recognize the pattern instantly. The cosmic web repeats itself here in miniature, a fractal echo of the universe that made it. Historians still argue whether beauty is objective or simply a trick of pattern recognition. You decide it doesn't matter. The repetition itself is the miracle. Atoms arranging themselves the same way at every scale, from galaxies to neurons to cities. It's as though the universe keeps sketching the same design, just to remind itself it's real. You drift closer until you can see rooftops, rivers, the gentle spin of wind turbines. The planet hums softly, a living counterpoint to the cosmic silence. You realize that this is what the universe sounds like when it dreams in color. The void is the canvas, life is the brushstroke. Maybe that's what dark energy truly is, not some exotic pressure, but the universe's urge to keep creating space for new stories. A fun reflection. The photons bouncing off your skin right now were born in the hearts of stars millions of years ago. They travelled through the local bubble, through the thin gas of the interstellar medium, through the gravitational pull of the Milky Way, only to end their journey in your retinas. Each moment of sight is an intersection of distances so vast they make language blush. You aren't just looking at light, you're catching the universe mid-conversation. You recall something from the very beginning of this journey. That playful warning you probably won't survive this. Maybe it meant the version of you that feared insignificance. That part is gone now, dissolved in perspective. The you that remains is quieter, stretched thin across 1 billion light years, yet somehow more whole. Emptiness doesn't erase you, it extends you. The atoms in your body once drifted through those same voids. Every molecule of water you drink was forged in starlight, cooled in darkness, reborn as rain. You are the universe remembering itself as a person. Historians still argue whether humanity will ever colonize the stars or fade quietly here on this blue dot. But when you look at Earth's slow rotation, it feels irrelevant. We've already crossed the biggest distance, the one between ignorance and wonder. Every telescope, every theory, every whispered bedtime story about stars is an act of communion with the infinite. Maybe survival isn't about duration but awareness, to know you are here, to look into the void and recognize it as kin. You land at last, softly, as though gravity has decided to welcome you home. The night air smells of damp soil and electricity. Somewhere a cricket sings. Above, the Milky Way arches like a luminous river, and for the first time, you see not darkness between its stars, but a thin, blue memory of all you've learned. The cosmic hole you feared has become something else entirely, a cradle of possibility, a silence that listens. You close your eyes and hear it, the hum of nothing, the song of expansion, the steady pulse of the universe existing because it can. You smile, breathing in the same air that was once stardust, and whisper a thank you to the void for its patience. The journey ends not with discovery, but with acceptance. The universe doesn't need to tell you its secret, you've been speaking it all along. The void isn't outside you, it's the space in which you think, the pause between words, the quiet that gives meaning to sound. You lie back under the stars, heart sinking with the slow rhythm of cosmic time, and let the thought fade like cooling starlight. We're not trapped in a hole, we're sheltered in one, and that somehow is enough.